Good morning, good evening, everybody there for the first session. Good to see you, APUEA, Reni, Ching, and Mr. Shah.
Hi, Raji.
Hi, Raji. Good evening.
So how do you do, Raji? You have got multiple screens or you change your login ID on the
I just started a 5:30. We started a session on smart communications with all the DOT, DOE, Telecom Engineering Center people in the other room. So we keep shifting the rooms. That's why this machine is also not registered in my name. Okay, we are on time. So good morning, good afternoon, good evening to all the participants from around the world joining this 8th edition of US-India Smart Grid Workshop, which we jointly with USAID, USTDA, and US Department of Commerce started in December 2014. Thereafter, almost every year we've been doing one edition. Last year and this year being virtual. Otherwise, and also along with the US Department of Commerce and other agencies, almost every year we have been, since 2014, we have been taking a delegation from India for a very large event called Disruptive Tech, which happens in US in the January. It did not happen in 2021. 2020, yes, we had taken a delegation, not very big because of COVID. Workshop just done. Yes.
Yeah, we lost you in between. Yeah.
Oh, I think some minor connectivity issues. You can hear me?
Yeah.
Everybody can hear me? Okay. So I was saying that we've been taking delegations from India in collaboration with US Department of Commerce and other agencies, and for Distribute Tech, a very large event which happens in the US in January, and which unfortunately in 2021 didn't happen. This year we were planning for January, but because again for the Omicron, it got postponed to May. So we'll be, we hope that situation will be good, that we'll be able to go. So every year at the Distribute Tech also we used to do a smart grid roundtable along with most of the participants there. So many of these discussions and dialogues which has developed into the US-India energy cooperation programs. So that many ideas which have been discussed and debated in these sessions have matured into real programs and projects, and the results of which are evident. And just 2 days ago, USAID launched a new program, SAREB, and a new fund, $12 million fund, SAREB, which was launched. And many new technologies will be piloted under that project. It is no more studies or recommendations and reports, which used to be traditional energy cooperation. Many of the places it used to be just reports, and reports didn't do much good for us. But in the last 5 to 7 years, we see we have graduated from studies and reports to real demonstration project, which is there for people to see, which is capable of replicating into and roll out as larger commercial projects. So I have the pleasure of inviting Ching Liu, Commercial Officer, for her opening remarks, and thereafter we'll hand over to Rollout Challenges, the moderator for the first session. So I stop here and I invite Ching Liu for her opening remarks.
Thank you very much. It's an honor to be here, and greetings to participants from around the world. My name is Jing Liu, and I am a commercial officer with the U.S. Commercial Service at the U.S. Embassy in New Delhi. And it's a pleasure to welcome you to the 8th US-India Smart Grid Workshop organized by the India Smart Grid Forum, the U.S. Department of Commerce, and the U.S. Agency for International Development, as well as the U.S.-India Business Council. I would like to give special thanks to Mr. Raji Pillai, President of the India Smart Grid Forum, for his continued partnership with the U.S. government in advancing the development of smart grid technologies in India across the power, water, oil, and gas sectors. The U.S. Department of Commerce's 7 offices in India promote bilateral trade by connecting Indian stakeholders with American technology providers. We're located in New Delhi, Mumbai, Ahmedabad, Kolkata, Hyderabad, Bengaluru, and Chennai. We help U.S. energy companies pavilions at Indian trade shows, recruit Indian buyers to U.S. trade shows, provide advocacy services, due diligence, and business facilitation services. One example of our work is the March 2018 Smart Grid and Energy Storage Trade Mission to India, which included business development meetings, commercial diplomacy, messaging, and industry networking in New Delhi, Hyderabad, and Mumbai. Following the trade mission, one participating company won a contract with the Maharashtra State Electricity Transmission Company. Since the beginning of the pandemic, we have also adapted by providing virtual support to U.S. companies. In the last 2 years, we have successfully organized virtual trade missions and business facilitation events, resulting in new partnerships between U.S. and Indian companies. Our office also facilitates investments into the United States through our flagship event, the annual Select USA Summit. Notably, in 2019, U.S. Ambassador to India, Kenneth Juster, led an Indian delegation of over 90 business executives to Washington for this event. If you are interested in the 2022 June edition of the event, please let us know. We'd be happy to help you get more involved. I look forward to the productive discussion today, and I would like to hand it now over to Apurva.
Thank you, Jing. And my job is a little different today because although I'm supposed to just moderate this session, my director, John Smith-Sreen, who was supposed to speak on behalf of USAID, has not been able to join because of some urgent work that's come at our mission. So I'll be stepping in for him as well. Just to, we have 2 speakers, I wouldn't say speakers, but 2 champions in the power distribution sector in the form of the Joint Secretary, Mr. Vishal Kapoor, and also Executive Director Saurabh Shah from the Power Finance Corporation. And I think we leave it to them to, talk about what the government of India is doing to modernize the power distribution sector as a whole, and what are the different initiatives they have taken. So before we do that, I just wanted to lay down a few context or a few things what USAID has been involved with government of India, particularly in the power sector, and particularly for today's topic in the distribution sector. So first of all, a very good morning to everyone, and it's also a pleasure to see that India Smart Grid Forum continues with its tradition of organizing the India Smart Utility Week, even through the tough times of the pandemic, even though it's virtual, but yet we are connecting, we are still discussing the challenges and the possible solutions and the advanced technologies that are making the power sector more dynamic and vibrant. Just to give a context of the US-India relationship, US and India share a very warm and a strong, long-standing energy partnership with a focus on innovation, energy security, and clean energy. In fact, just to give the level of this partnership was started off as a dialogue in some yesteryears, but then it got converted into a strategic clean energy partnership between the 2 countries 2 years back. And last year, again, it was elevated to a much higher level when Prime Minister Modi and President Biden launched the India-US Climate and Clean Energy Agenda 2030 partnership at the Climate Summit in April last year. We are very proud of this long-standing partnership with the Ministry of Power across the entire electricity value chain, right from generation to transmission to distribution and energy efficiency as well. In fact, distribution sector reforms have been a key focus of USAID India's collaboration with the Ministry of Power. We already have our ongoing bilateral program called SPARK with the ministry, where we have supported the ministry in a lot of elements which the new distribution revamp scheme now has, which is smart meter deployment, building capacity of the DISCOMs, institutional strengthening in the form of Smart Grid Knowledge Center, developing tools and technologies, working on AI/ML cases, and so on. And Reggie initially also pointed out that we want to move from, in fact, we've already moved from the paper and the reports that was done maybe 10 years back to actual deployment and making a difference on the ground. And so, I mean, our work actually started on smart grids when we designed the first pilot, which was with Ajmer Discom, as a pay-for-service pilot. That was in around 2014, when the government of India had its own 14 pilots, but they were in various stages of deployment. None of them had reached a logical end. And that's when we in the ministry requested us to come up with a 6-month straight pilot with a different business model. And we went in for a pay for service, which then became the business model for ESL and then IntelliSmart. And even now, the new latest standard bidding documents talk about that kind of a business model. So from there, our journey on smart grid started, to smart grid regulations, then to the support that we provided to the institutional framework of the National Smart Grid Mission. Then it went on to, working on right from the concept to the, rollout strategy for smart meter deployment. So, tools and investment tools to be were developed. And then, we had the entire consumer engagement toolkit that we developed for smart meters, and we keep building on it. Now we have another program, which is called the South Asia Regional Energy Partnership Program, where we are again working with the ministry and particularly with Power Finance Corporation and pretty closely with Saurabh here, on various aspects of how we could improve the distribution sector, and particularly on the key elements of the RDSS scheme. So these are some of our, engagements we are going to build upon. We are going to do a lot of proof of concepts, pilot demonstrations, but our focus would be mostly on large-scale deployment at the state level in this new program. With that, I would now like to request, Joint Secretary Vishal Kapoor to, deliver the keynote address. Vishal has an engagement, so he has to leave early. So we've slightly shifted the agenda to have him speak first. Vishal Kapoor is the Joint Secretary not only for distribution, he's also the Joint Secretary for cybersecurity, IT, social media, languages, and so on. And he's been with the ministry for now 6 to 7 years and has a lot of, he has, spearheaded the RDSS scheme, but even before that, the UDAY scheme, the IPDS, and the smart grids, a lot of efforts that he has spearheaded, and, is really the champion in the power distribution sector. He comes from the railway services and is a mechanical engineer. But he also has a strong background in public policy, having, from ISB as well as from Singapore University. So over to you, Vishal, for your keynote address.
Thank you, APUEA. Thank you very much. Am I audible?
Yes.
Yeah, okay. Good evening, everyone. Thank you very much, USAID and ISGF, for inviting me to this event. From the times that we were at the time of our independence, when we had only 1.2 gigawatts of overall capacity, generation capacity, we have traversed a long way, and we are now almost 400 gigawatts of capacity. We also have a lot of transmission capacity. We can transfer as much as 120,000 megawatts of power from anywhere to anywhere in India. Household access, energy access, universal access, that was a dream for several years, is now a reality. We have been able to connect all the households with the grid, or wherever not possible through the off-grid mechanisms. And we have now come to a stage where we are increasingly bringing consumers into the focus. Quality and reliability of power is of paramount importance, and so is the imperative of increasing renewables as a part of the NDCs of the government that the government of India has committed. We do have significant challenges on the financial sustainability front. We lose almost 20% of the electricity, which is unbilled and uncollected today in our networks. Several countries, our peers, are much lesser than this level. The advanced economies are at levels of 4 to 5%. A lot has to do with the way the networks have been designed. High voltage networks traditionally have low AT&C losses. India has chosen over a period of time the European model, and which has a lot of LT networks, and that's why we do have inherently high technical losses in the networks. But notwithstanding that, the overall losses because of the commercial inefficiencies are pretty high. Indian utilities today lose almost around 60 paisa for every unit of electricity served. That underscores the biggest challenge, and that is to ensure the financial sustainability of the sector. What we are seeing as an outcome of these problems is I think, manifests more into things like Genco overdues mounting. We have almost around 1 lakh crore worth of Genco dues only, with the major stations discounting the state generators. And all these problems have come together. And the good thing is that we do not have to now focus on the electricity access. Now our focus is clearly on financial sustainability of the discounts and how to solve these issues. And various measures that have been taken by the government, like additional borrowing scheme and also the revamped distribution scheme, and even the liquidity infusion scheme that we had launched to bridge the liquidity gaps arising out of COVID, they have some underlying principles. Number one is the governance issue. The governance issue has a lot of, if the governance improves, things automatically improve. Governance issues include several things like corporate governance, maintaining a proper arm's length distance between the states and the discoms, going in for a rules-based order, changing business processes, changing business strategy, and these kind of things. How to engage with consumers. So, but this is something I would like to leave here for the time being. The second most important thing which I would focus is basically the utilization of technology and how technology can help us overcome these challenges, these financial unsustainability, and how technology can be used to make the system devoid of maximum human interfaces. So what is required probably today in the Indian context is, it's not only about the technology, it's about infusion of technology which is smart and done smartly. So both these things are important. IT and OOT, we are seeing there's a lot of convergence happening today. Lines demarcating these two are getting blurred over a period of time. Host of applications are available outside, like drone applications for condition monitoring and asset monitoring of assets, and these kind of things need to be introduced progressively into the distribution side, which is currently now being used in a big way in the transmission sector. Unless one of the major things that the next things that what we are looking at is, unless the humongous amount of data being generated by the OT systems is not analyzed and put to use through suitable IT analytics, big data and AI applications, we would not be even touching the tip of the iceberg that we want to create. The ministry has taken several initiatives on innovation surrounding AI and separately for the complete distribution sector also. We all know USAID has been our partner in creating a full ecosystem of AI-based interventions under the revamped distribution scheme. They have provided assistance to REC in this measure. Secondly, one major thing is that which is coming in a big way is the platform orientation. You talk about Uberization, you talk about Zomatos, you talk about any kind of good, successful app that is coming out, that's basically platform based. And recognizing that utilization of platform based approaches provide a great outreach with a minimal marginal cost of replication of information. We are also launching a platforms based system for scaling innovations shortly as a part of the Smart Grid Knowledge Center, which is being virtualized, and we are hosting. We are launching this in partnership with USAID, who have helped PGCIL to create this ecosystem, and we'll be doing that very shortly on the 8th, where Honorable Union Minister of Power will be inaugurating this platform. And I'm sure, I mean, the kind of applications, innovative approaches that will come on this platform will be available to any person, whether he's in Kanyakumari or whether he's in Rangia in the northeast. So anybody sitting from his room will be able to access this information. To that extent, the information asymmetry that exists in terms of good technology, that will get reduced. We also know that we cannot subsidize into prosperity. However, given the affordability issues, the Electricity Acts do allow subsidies to be provided to the consumers. And what we have recently done is that we have tried to bring a convergence between the Kusum scheme of the MNRE and the RDSS, under which we plan to segregate all the agricultural feeders. To our information today, we have almost around 90,000 agricultural feeders, a large percentage of which has already been bifurcated. There are a few which need to be bifurcated. We are providing funds to the states to bifurcate these feeders and then solarize them under Kusum scheme. Even the existing feeders will be solarized under Kusum scheme. This is a win-win situation, win-win kind of an intervention for everyone, simply because of the fact that the revenue subsidies that are going out to the consumers as of now will get converted into a capital grant. Instead of providing revenue subsidies, we create infrastructure, create jobs, create a full-fledged investment ecosystem, the benefits of which will be reaped by everyone. And this generation of solar energy over and above the use of agriculture can also be used by the DISCOM into their own energy requirements, which again provides a good opportunity for almost free power to the DISCOMs. India, USAID specifically, we have been having a very long engagement. At least I have seen for the last 5-7 years, USAID has been a very reliable partner in various interventions. We have sought for whenever we have had any kind of a requirement. I think USAID is an organization we always bank upon. A lot of work has been done. A lot of work also turned out not to be coming out in the open, but then it was a lot of work. It was knowledge co-creation. Everything does not actually lead to an outcome. But here is one intervention with USAID, which has led to a lot of outcomes. I think a lot of outcomes, a few not materialized, but then the amount of information and knowledge and the insights that have come to us have been phenomenal. For example, when we worked on various interventions such as trying to develop PPP networks, we realized actually what exactly are the challenges, because the earlier on when we had issued a standard bidding guideline for input-based franchisee, it was being adopted, but then there were some problems happening everywhere, and when we started tweaking them, then we realized what exactly is the problem with the input-based franchisees and how We could surmount them, we could not, but it was a real eye-opener to us. This journey with USAID, I just hope that we continue this journey ahead. We have a lot of things that would be coming up very shortly. I think in a new role, I think there has been a very good alignment that is shaping up with PFC. In this particular assignment, I would very looking forward to this on the scaling side, capacity building side. And Saurabh is here. I think he's been new to this sector, but let's say 10 months. But the way he has taken the leadership of the distribution side from PFC, I'm sure PFC and USAID will be able to take forward these important measures. In fact, through PFC, I think USAID is also teaming up with the NPTI, and these are certain things that have not been taken care of, and I'm very happy that this thing is also shaping up. I think and I hope we have proceeded ahead on our discussions last time. In change management, building narratives is extremely important. I mentioned specifically about this knowledge co-creation and this process of engagement that creates so much of information and understanding that it helps us in understanding what will work, what will not work. These kind of narratives that are being created by these kind of conferences, webinars. Thanks to ISGF, ISGF has been a pioneer in this, because I think every year, so many times, so many events keep on taking place, and this actually helps build the narrative. We took almost 6 years to build a narrative of smart metering in the country, and now we are in a situation where we have been able to soften and take everyone along. Thank you so much working this out. I wish this workshop the very best in their deliberations. Thank you very much, and APUEA and ISGF team. I would like to just say that I'll have to leave because I have an engagement.
I understand. Thank you, Vishal. I think it's been a pleasure working with you for the last more than 6 years, and jointly we've faced a lot of challenges, tried to overcome some, and as you rightly said, some had distinct outcomes, some didn't, but there was a distinct learning curve with you and the ministry. So look forward to working and engaging with you even more closely. Thank you, Vishal.
Thank you very much for the kind words.
Thank you.
So with this, I'll move on to Saurabh. I know Saurabh Shah, who is the Executive Director for the Power Finance Corporation. He is new to the power sector. He's an IPS officer from the Bihar cadre. And even though he's new, just a couple of months old, and I've had the pleasure of working with him on the new SARE program, as Vishal just alluded to. Yet the way he has picked on the nuances of the power sector, particularly the distribution sector, in a very, very short time, is something I deeply kind of admire, I would say. We have a very close, intensive engagement with PFC, and sort of anchors that engagement from the PFC side. And he's also, PFC is the nodal agency for the RDSS scheme as well. So his insights on what their plans are, how smart meters and other aspects of RDSS would be deployed at the state level, we would like to hear from you, Saurabh. So over to you.
Thank you very much, APUEA, USAID, and ISGF, Mr. Reggie, and everyone for organizing this event despite the adverse situation. And a lot of what I had to say has already been covered in the macro picture by Vishal sir just before me. Incidentally, I have to go to the same meeting, so I'll be short because of that. I'll focus on the smart metering part of RDSS as the financial stability and the overall result-oriented mechanism of RDSS has been explained by the Joint Secretary in detail. So unlike the other Government of India schemes preceded RDSS, there was a lot of, they were essentially milestone-based schemes where you had to perform or create a certain level of infrastructure to avail of the next tranche of funds. However, with RDSS, the change has been that every year there'll be an evaluation. There is almost a concurrent evaluation, and the entire funding financing will depend upon the performance. So there is a pressure to perform, there is a pressure to reform, or there is at least some kind of, there is a gentle nudge to reform at all stages. And I think this was essential, and this was the kind of scheme that was essential that should have come in the power infrastructure, power distribution sector. There is also a reason that this is happening now in 2022, because as Vishal sir was mentioning earlier, that access is less of an issue now. So earlier, I mean, there was a greater focus on access, on reaching out. Now that we have reached a fair level of access, the transmission infrastructure is in place, and the entire, I mean, overall volume, or at least the generation, is no longer, at least in the medium term or the short term, it's lesser of a problem. So we can focus on these essential reforms, which will ensure that our sector stays financially sustainable. And if distribution stays viable, if distribution stays financially stable, I mean, that will transmit to generation also. So a lot of the woes and ills that we have in the power sector will emanate from distribution sector issues. Here, I mean, again, smart meter will lie at the heart of these interventions. Every year we lose almost 21% to technical and commercial losses. So even if we have a ballpark figure of 5 or 6% coming in from collection efficiency alone, which can be addressed by smart meters, be it from the government use part or be it the domestic consumer. So every single percentage point will amount to almost 1 lakh crore. I mean, the kind of savings that can come from smart meters. We have had some experiences. I mean, in IPDS, we were able to install around 11 lakh meters as we speak. So these numbers will look very small compared to the task at hand of 25 crore meters. But what these projects did for the states that were able to take it up, like Bihar, like Madhya Pradesh, they are the most enthusiastic supporters of the new smart meter program also. I mean, these are the states that are going for big NITs, and they have the least resistance, and because they have seen the benefits coming in there. I mean, the use case has to be some kind of commercial return. This has happened to these discoms, and that's the reason, I mean, they are the most enthusiastic adopters. At the same time, all other states, I mean, there is some kind of peer learning, and other states are also coming in. We are also running a concurrent consumer engagement where USAID were also very helpful. I mean, the program will run a consumer engagement, and we are also doing the skilling part of the program, for which NPTI has initially been identified. We'll be using other organizations also, and together in skilling, we'll also look for some kind of behavioral orientation and attitudinal orientation, because the last point of contact, the person who's actually changing the meters, he should also have the right attitude. He should have the right connect with the individual, I mean, individual consumer, the individual household. The household should not have a fear of a price shock or a fear of some kind of unknown. So it's essential. I mean, both our DISCOM employees or be it the consumer who's the target of the program, as well as who's the partner in our program. I mean, they should be on board. So this consumer resistance will also, I mean, we have been seeing some initial instances, and we are happy that, I mean, so far we are able to bust a lot of myths and get across these with our consumer engagement plans. Also, I mean, right now there is a test bed we have been using, so that we'll be able to install, we'll be able to empanel some vendors who have ready solutions. I mean, especially this is in the interest of the industry also, in the sense that what kind of solutions will work, so that once the program actually takes off, there are fewer roadblocks. So upfront, we'll try to solve some of these issues so that the rollout that happens later in the scheme life is much smoother. So I think the next 1 or 2 months are crucial. We'll be able to get the motive force going. States are coming in with their own action plans. Scheme is being sanctioned. And I hope by the end of March, mid-April, all the states will have a working plan for the RDSs, not just for smart meters, also for the loss reduction and the modernization elements. Smart meter is also an interlocked feature, because if states do not award smart meters, or if they're not able to start with the program, they'll not get the other benefits of the scheme. So I think by mid part of this year, the governance issues, the technical issues that have come from the global chip shortage, all of them will go away in some measure, and we'll be able to see a ramping up of this program and much better numbers than what we shared. So, with the support of industry, and so far we have had a lot of industry level interactions, right from the building of SBD to the test bed, and at every level we have had a lot of course corrections, which helped us build a better SBD, which has helped us design a better program. And hopefully in the next 2 to 3 months, we'll see the program in full swing. We'll see faster installations, better consumer experiences, and declining consumer resistance. So this is our hope from the smart meter program. I'll have to, I wish I could have taken more time, but there's another meeting that's on. So I'll take your leave, and thank you very much, Apoorva. Thank you very much, ISGF and Reggie. So
Thank you, Saurabh. I think even in a very brief remarks by you, you kind of gave a glimpse of what PFC intends to do, or the Government of India intends to do in the smart meter, as well as the distribution sector at the state level as well, and how you are engaging with different stakeholders on that. So looking forward to continue collaborating and expanding our partnership with PFC in the distribution space, as well as other areas as well. Thank you for your time. I know you have to leave for this meeting, which the Joint Secretary is spearheading right now, so won't keep you here. Thank you.
Thank you, Apoorva. Thank you.
So, Reggie, my apologies also. I had committed earlier for the entire, session, but we have something very urgent that's going on at our side. So I will also be taking leave and handing it over back to Reggie and perhaps to Rahul. Nice to see you, Rahul.
Reggie? Reggie, are you online? Thank you, Apoorva. So I'm Rahul Tongia. My bio is online. I won't go through it, but I'm a scholar, a researcher interested in sustainable technology and the policies around them. I'm also founding advisor of ISGF, and a body I've been associated with from the start, helping set it up. And it's my pleasure and privilege to moderate this session, because the action, I mean, theory and academics is one thing, but the rubber hits the road with deployments, with learnings, which then of course need to scale for the Indian context. And that's why this sort of having experts, Indian and US, or US and global companies in India, is very important, because smart grids may have heterogeneity, but there's also lessons that are learned globally. There are lessons from states in India that are learned for other states, even though, of course, we know rural India is very different from urban India, for example. The US is also, and this is relevant, yesterday I was moderating a session on regulation. The US is also a federal structure of regulation like India. And so that's also an interesting overlap between the US deployments and designs like India. So with that, I want to first welcome all my panelists. I will not formally introduce them because I would not be able to do them justice. And with many of their backgrounds, I think it would take some time to go through many of these. But I'll now first turn over we'll switch the order around. I know some of you have to leave early. So we'll request Shri Anil Rawal, the MD and CEO of IntelliSmart, which is the arm with the ESL focused on smart meter deployments. If you could share your remarks, please.
Sure. Thank you, Rahul. Hope I'm audible.
Yes.
Yeah. Thanks a lot. First of all, thanks a lot for having me. And our topic is something so well proven that I don't know whether we need to emphasize this. It says role of advanced metering infrastructure in DISCOM's modernization, right? So we are almost all of us in agreement that AMI is going to go a long way and it has got proven also through whatever 3 million meters have been installed in the country, to the extent that majority have been done by ESL, but still the program has proven for itself that that this would go a long way. As far as my introduction is concerned, means I'm MD CEO of IntelliSmart, and I've been there for about 2 years now, or going to be 2 years, and we have done more than 1 million meters in last COVID times, and are aspiring to do far more, and as the time go ahead. So now, would you like me to cover my portion, or would you like a first introduction and then probably cover whatever way you feel?
I think it may be best if you jump in, because that'll save the back and forth, perhaps. And also, you will help set the tone, I think. So that'll be very helpful.
Thanks a lot. And I'm a bit onto something else also. The RDS's review owned by Power Secretary, so I may have to drop, but then let me just try and do justice with whatever content I have. So I have few slides, not more than 4 or 5, and I can quickly try and share them, and let's see if that makes sense for all of us in terms of understanding or sharing ideas among each other. Just 1 second. Just confirm me when it's visible, please.
It is.
Okay, thanks a lot. So about IntelliSmart.
It's not full screen yet. If you could please put it into full screen mode.
Just a minute. Yeah, hopefully it is.
Yes, thank you.
Thanks a lot. So IntelliSmart is an NIF majority company. It's a quote unquote private company supported by ESL and NIF both. And our aim is the digitalization in the utilities. Our core purpose is to be the most preferred digital partner of the utilities, right? So it includes obviously smart metering. That's the first and foremost target of IntelliSmart, right? Going to next slide. Just a minute. Problem is that these things get stuck. Let me just share again. Yeah, it's getting. Yeah. So coming to the point that how AMI can help in terms of modernization can only happen when we have good financial and operational efficiencies in the system, which are suffering terribly today in the country in the distribution sector. We are to the tune of 20 to 23% stated losses. So we are in bad shape, and more than 1 lakh crore rupees is being lost almost every year in utilities, and we know the numbers are, even if they're not perfect number, they could be plus minus something, but massive exchequer drain is happening. And that's making our utilities not self-sufficient, not in control, and obviously not modernizing. So it's a self-perpetuating vicious cycle, right? And how can we correct it? Obviously through smart metering. Smart metering would actually handle large chunk of losses in terms of billing and collection. Our experience so far with whatever 2.3 million meters have been installed, the billing and collection efficiency is touching around 98-99%. That actually plugs a major hole in terms of the losses, and then you can obviously churn out this money for your network improvement, and that's where you lay the first foundation of the modernization in the grid. And this is a broad program which is actually is now being seen as a DBF40 program of Government of India also, that you have a certain build-up phase. Now utilities don't have the exchequer or the money to spend upfront, so you support them with the OPEX program, so that because this is self earning program for itself, so basically installation of the meters makes a real big milestone. So you install them and you don't charge anything, and once they get installed, you improve your billing and collection efficiency, so the revenues improve, and you feed the program for that revenue for the developer, which is called AMISP, service provider, as well as to the DISCOM. So basically you have built-up phase, you have the O&M phase. You don't charge in built-up phase and charge in O&M phase, a monthly service charge, and that's the way whole program is structured. Yeah? And the aim is that you don't charge upfront because they are not in good shape to start with. So currently where the program stands, this is a summary. About out of 78 lakh meters, 23 lakh meters, as I said, have been installed. In other parts of the country, other than ESL IntelliSmart, 16 lakh have been installed. About 39 lakh meters have been installed in the country. But then that's that's a small thing to say, because the fun lies, or the excitement lies in the journey which is in front of us. Means more than 3 crore meters are under tendering in different parts of the country. Various states are tendering it, and it's under the standard bid document and notification by Government of India. So it's going to be very competitive, healthy churn in terms of various developers who would come in. IntelliSmart could be one of the many developers. We would also compete, and that's going to create a very healthy competitive environment. And we hope to really get our share and do best in terms of the lessons which ESL's projects have given us, and really help the country in terms of mobilizing this effort.
Anilji, if I could just go for clarification in this slide, previous one, you have segregated smart meters and prepaid smart meters.
Yes.
Is that going to continue? Because in theory, all smart meters can operate in a prepaid mode, or at least that's the planned design going forward. Could you just clarify on that?
That's very right, Rahul. The all meters to be installed now under the new revamped distribution scheme are smart prepaid meters. But the meters which were to be installed by ESL previously or by others did not have this compulsion. So meters installed so far are mostly postpaid, other than Bihar. Bihar is completely prepaid flagship program of the country which ESL is running. That's why you will see a very small number of installed prepaid smart meters. But you are very right. All the future bids and all the future projects would be on smart prepaid meters.
I mean, that's just a design tweak. In theory, the architectures and the technology can enable all of these use cases. So
Exactly,
I think
you are right there. So yes, architecture can enable all, even the postpaid meters installed to convert to prepaid. You are right there.
yeah.
Yeah.
So, thank you.
Sure.
Sorry to interrupt. Yeah.
Yeah, that's perfectly fine. And so coming to modernization part, why smart meters form the backbone of smart grid and modernization. Some of the aspects I've tried to cover here. It could be seen in terms of remote operations. We know that there's a basic utilization of the smart meters in terms of improving your collection efficiencies, where you can do remote operations. Time of day, time of use are, as of now, are more of theory. They can be converted to practice when we have some control and command which can be done from the remote, so that could be implemented. Smart grid obviously needs a first backbone of smart meters. So we can see stepping stone smart meters. Stepping stone means this event is stepping stone towards smart grid. So that's one real time action which can lead to the smart grid situation for the country. And then demand response, we know we need to have better demand response, because we are adding so much of renewable in the country, so much of integration issues, so much of variability, and our grid is not really flexible in terms of having less of gas, less of hydro, and not much of storage also. So you need to have demand side management extremely good to handle this new situation of having higher and higher renewable integration. So that's where that it's not an optional situation anymore. It's rather a mandatory thing that you move to smart metering, and the modernization of the grid has to happen to smart metering. And then AI ML based interventions, they are obviously very critical. We know the data is a next big treasure for discoms. Can they earn money through data beyond selling of power? So that's a massive big thing waiting for the country to really roll on. We have done our first project in Haryana. We have completed the pilot project. Results are really exciting. Haryana is also excited about the AIML project, pilot project, and we want to roll it out in a bigger scale across the country. And then many futuristic technologies, when you have EV charging in a larger scale, whether grid can tolerate that variability, whether your grid at the last mile is strong enough, and whether there is a slack in the grid which can be utilized, that requires lots of real-time responses. That's where, again, if you want to make EV program successful, you need a real-time response. That's where, again, AMI becomes a critical input. So there's a few, I'm not saying this actually I've covered everything, but largely speaking, some of the low-hanging fruits of AMI installation could be seen in terms of modernization, which I have listed here.
Thank you.
Yeah, so just one last slide. We have done on data analytics, as I said, the Haryana project we have done. I just wanted to highlight the use cases which we have done. And on the right side, we have listed the use cases. So one was anomaly, theft detection, billing ratio, contracted demand, high bill generation analysis, and complaint defaults. These are the 5 use cases which we did in Haryana through our AIML project, and the results have been very good. We have done the baselining in September 21, and in February the project got completed, and we have the results. It is a significant improvement over the baseline. So it has what we are looking forward to now, really roll it out in a big way, and that's a, I think it could be game changer in terms of additional revenue source for discoms. And that's all, Rahul. I don't want to take too much of time, and that's all from my side.
Thank you very much. You've painted a very wide landscape, which is important because the Indian scale is so vast. The numbers you've shown are bigger than countries in Europe, but at the same time, for the needs ahead, we're just starting or in the earlier stages of this journey. One question, if I may,
Yeah.
the rollouts that I've seen, ESL and others, have been disproportionately urban. Rural is not yet taken off. And so one question is, do you see rural starting up soon, or do you see saturation or more focus on completing some of the urban first? Because rural is a very different beast.
I got it. This is a very valid point again. So there's small correction here. ESL projects is actually a mix of rural and urban. There's some real hardcore rural areas which were really almost
In
zero
some
in terms of,
states, in some states,
in some states like Bihar,
they are
some parts
correct.
of UP.
Yeah.
Haryana was largely urban. You are very right there. So it's a reasonable mix, but I would say that these the tendered projects by different discoms now, or different state utilities now, are having good mix of urban and rural. I think both things are going to pick up fast.
Okay. Look forward to seeing more results from the rural, because that's a more challenging scape. Thank you very much.
Certainly.
Um,
Thank you.
we're going to switch the order around because Dr. Ganesh Das has to leave for another meeting as well. Dr. Ganesh Das is, of course, an expert in technology, innovation, wears several hats, but his original focus used to be on technology at TPDDL. But I'll leave him to describe his current hats that he wears, since I cannot do them justice, and look forward to your thoughts and points on distributed energy resources and toolkits.
Right. Thank you, Rahul. Presently I look after strategy, innovation, collaboration, R&D at Tata Power Delhi Distribution and some part of the Tata Power ecosystem. And also I head the Clean Energy International Incubation Center, a joint initiative of Tata Trust, Government of India as its CEO. So this is about me. What I would like to do is, one important aspects of smart meters has been touched. Smart meter is going to drive a lot of applications and provide a lot of opportunities to use data, information, and create flexibility in the grid. At the same time, the distributed energy resources are going to be a big reality, because if you really look at the kind of commitment India has driven with respect to net zero 2070, we are planning to be net zero. We are having a good targets for the solar generation, the wind, etc. The renewable integration is going to be critical. While it is going to happen, the important aspects of the important point of having the distributed energy resources at the grid level is something which is going to be critical. So what we will try to do is, we did have a funding which has come from the USTDA, because we have been having a great support from the USTDA all the time, and of course the US organizations like agencies like USAID, USCA, we have been working with all of them. So I will just try to say that one of our latest project which we work with on the USTDA funding, we did a couple of projects of the distributed energy resources. First phase was, we tried to identify what is the potential rooftop potential in Delhi. Then we realized that rooftop potential understanding and setting up rooftop is not only going to solve the problem with respect to the utility and handling different applications, it has to be more of an integrated aspect. So we looked at that through this study, and in that process we also developed a toolkit for doing that. So I just take you through very briefly on the discussion what is about the project and how we did it. I hope you have been able to see the change of screen.
Yes, the slide is there.
Yeah. So there are three trends in utility which is really talking about. One is, of course, the technology which is driving everything. It changes in the data, communication, new technology which is happening, which is cost effective, but also we are trying to discover applications of a technology. And real value of technology comes in when we have translated that into an application and a value. And today, still, there are some of the straight calculations like AT&C losses, theft, etc., where it is much easier to calculate. But the reliability part, the quality of the power, those things are still, we are trying to find some tangible value to relate to the benefits. Policy, climate change is going to make massive changes in the electricity distribution. And perhaps in the grid which we talk about, the policies we are talking about, that particular component is not there. How do we really look at that? Consumer is going to be more participating. They are going to control. They are more vocal. They are going to say that, if you are not going to give me a good, I'm going to set up my own rooftop generation. I'm going to put up storage on my own. There are going to be regulation which is going to facilitate that. We already see in a gated community this kind of applications coming in. So India is essentially in the crossroads with respect to the energy sector. Declining cost of renewables, strong economic growth, higher consumer and industrial tariff. That is one of the favorite topics of Rahul. We always discuss this part, that always the industrial and commercial tariff, consumers are subsidizing the domestic tariff. How long this will go? Air pollution from the power sector, and then the transportation sector. We are seeing a convergence of the transportation sector with the power sector through the electric vehicle. How does the do that? So the DER could help the utilities to prepare the future and prepare for this climate change. I would like to put it this way. And if you further this aspect, and then the background I mentioned, it is funded by the USTDA. This is one of the second projects on the DER resources. And essentially the whole idea is, how do we really create a better world, better acceptability of the renewables? We have looked at different DER programs, and we did. There are certain pilots which we did on our own. And how do we really, what are the results of the pilot, etc., is something which we can briefly touch upon. And how do we really develop a tool which can be used by all the utilities in the country? That also is something which we very consciously looked at. And if you typically look at the landscape which you are talking about, we are looking at the generators, your transmitters, distributors, behind the meters. The DR value stream in terms of how do you really avoid the energy usage, how do you really avoid the generation capacity, avoided transmission capacity, avoided distribution upgrade, and avoided losses. That is where the value stream of the DR would come in. And if you are looking at totally from the tangible money perspective. And otherwise, you look at the local congestion zones, the C&I behind the meter customers, how do they really work around the demand charge reduction, the electrical retail rate arbitrage, etc. And how do you really look at the, optimizing the grid and create flexibility and develop other revenue stream business model rationally to adopt storage as a business, because in the budget this time, storage has been treated as an infrastructure. So what are the different stacked up value of the storage, which is going to support the revenue stream when it comes to DER, be it energy or ancillary services, etc., as we move forward on that. And while preparing for the DER, DER valuation on one side, DER pilot deployment, again validating the evaluation of the DER for your energy capacity, environment benefit, the customer value proposition, etc. And how does really it work at a pilot stage? How do we really use this outcomes of the pilots and outcome of the positive side of the pilot to get a full regulatory approval, so that it becomes part of the design when it comes to any distribution utility, utilize the program experience to launch fruitful program, and then add higher DER value technologies. As the technologies mature, India integrates more renewable, bringing more focus to the DER programs, and then the grid storage, automated controls, home automation solutions, everything starts coming in and start playing around. So what we did here is we looked at the drivers in terms of the savings. We looked at the consideration, policy aligned, cost effective solutions at three levels, at the programs which utility will offer, programs with the consumer are going to be interested, programs with the regulator are going to approve. All three dimensions, and the objective in looking at leadership earning through regulatory compliance. How does the regulators see a value and say that, okay, I'm going to use it in Delhi, how can I use it in other parts of the Indian ecosystem or the federation? How does this works together? So while we looked at the evaluation of the DER program, we looked at typically the valuation framework is used to estimate the net cost of all the DER programs. and how it can help us to reduce cost. So technology program cost, the awarded generation, transmission, the life cycle benefits, the life cycle cost were looked at, and the net benefit is looked at. And then based on this, we designed a toolkit. In how does this toolkit helps us to arrive at different, and you can imagine the kind of data, the kind of small nitty-gritties would go in developing the toolkit to really arrive at the value. I mean, the whole idea of understanding the value is to go to the regulator and say that there is a recognized toolkit wherein we are able to calculate this is the benefit which is going to come for different programs of the year. And there, also, if you look at the larger evaluation, you looked at the total cost, resources, the participation, and the what kind of benefits, and what are the non-participation, etc. on that. I mean, again, a total resource cost, the total participation cost, the ratepayers impact measured cost. I mean, typically this is the model which has been used in US very effectively to understand how does non-participation also can benefit, how does the participation can benefit, and how does this entire thing affect the utility ecosystem per se. And some of the things, after having looked at all these things, we arrived at these 6 areas. Electric vehicle charging infrastructure, which support electric vehicle charging infrastructure, would again be benefit when it comes to the DR program. The demand response hotspots, this would also throw some element of understanding. Can we have some behavioral based demand response program? We did a automated demand response program, which was largely equipment oriented to move to the DR hotspots. Grid storage, integrating high value distributed and grid scale storage into the ecosystem. We also looked at some very specific cases of pole mounted storage also, which is going to come into the grid. AC setbacks, because we are predominantly looking at the behavioral part, because if you look at the summer peak for Delhi, it is predominantly AC load which comes in. So can we look at a AC setbacks or tweaking with the temperature to help us to look at a potential saving out of that? Energy transition tariff, can we say that there could be a policy wherein the consumer will be interested to commit themselves to the renewable energy transition, and what kind of incentive the utilities can offer through, of course, the regulated process of approvals, etc. How can we then therefore get out of the some of the commitments of long-term power purchase agreement with the generating stations and bring this to the advantageous situation to enable it for the consumers? Wall-to-wall optimization, essentially looking at the integrating it and also looking at using technology to detect theft, looking to optimize the quality of the power on that. There's some of the illustration which I would like to just glance through.
If I could request you to, yeah, because we are a bit behind schedule.
Okay, sure.
Thank you.
So just a couple of cases. We looked at how does this e-rickshaw program would be very useful, how the demand response program would be very useful. Then we had arrived at something like what sort of a scale-up program, what pilot program we need to do, what kind of an evaluation we need to do for different programs. The whole idea is to sensitize to the fact that there exists a toolkit, and it's an Excel-based Python-backed support system which optimizes the entire data which you put in, and which gives us a plan that what is a kind of an benefit and cost benefit which will give us at the end of the toolkit. Then when we talked about smart power grids, going beyond the traditional approach, what are the different benefits, how it improves the reliability, how it supports the supply reliability, green energy, data analytics, customer empowerment, system security and control, integrating DR into the whole utility ecosystem. Thank you for your attention. I understand that the toolkit is not so easy to run through, but given the constraint of time, we'll be very happy to discuss it subsequently as we move forward. And we are also trying to develop the toolkit in a much more user interface manner, or user-friendly interface manner, so that it could be very easily used by other utility. Thank you very much for your attention. Thank you, Rahul, for the flexibility.
Thank you, Dr. Das. So Ganesh, if I could just clarify, your toolkit, of course, has been optimized or designed with TPDDL. Now, other utilities are differently placed on their smart grid journey. They have a different consumer mix. Delhi, for example, the value of land, rights of way, congestion is a very big deal. So I guess these are all things that could be modified or modifiable down the road as other utilities want to deploy these techniques, these sorts of tools.
Yeah, absolutely. Because it has got that field, and that field is can be universally used by anyone. So you can what is applicable for the land in Delhi and land in Bangalore. All those variables are there, so it can be used by anyone. And but it is not so easy because it's you understand that using Excel is a little bit of a challenge along with that. So we are trying to make it more friendly so that you are able to input data in a much more friendly manner, typically in the way everybody is used to doing it, not making it very complicated. And it may take us some time to convert that into something which will be very friendly for using to all by all.
Great. Looking forward to the next avatar and iterations of these, because certainly usability is key. Doesn't matter how great a tool you've built if people don't use it. Look forward to that. Thank you.
Thanks.
I would now again switch gears, and we'll come to actually first session C because people need to leave. And our speakers here ostensibly talk about drones, but also the larger points of harnessing technology and predictive analytics for this space. If I could first ask Dr. Ashutosh Nataraj, who's the co-founder of Vidrona, to share his remarks. Ashutosh, you're online?
Hi, Rahul. Can you hear me?
I can, yes.
Perfect. So thank you so much, Rahul, for the opportunity, and as well as the ISUW and the USAID, which is organizing this thing, because we started working, interacted with SARE program. So I know that it is very much interesting in terms of connecting and to start seeing how we can actually look into this particular scenario, because it is actually quite an interesting topic. And today, what we are doing is that we are presenting. Let me share my screen so that it gives a better. If you can just confirm if you're able to see my screen.
Yes. Not yet in full screen mode, but yes, it's visible.
Right. So, hi everybody. So, I am Dr. Ashutosh Nataraj, and as Rahul introduced me, as I'm co-founder and CEO at Vidrona Limited. Today, as we are talking about how AI and other machine learning or different sectors are actually combining to enable high-performing modern utilities, because the challenges are quite different, and so hence we are trying to focus more onto a particular topic, that is on the how AI can help the utilities in terms of going for a predictive and analytics platform, so that they can benefit from the platform that will help to reduce the overall maintenance cost, as well as make the entire process faster. Because the key behind this is that all the utilities are heavily regulated, and the utilities are constantly in the pressure to deliver uninterrupted and reliable electricity while maintaining the profitability. So it becomes quite crucial that how this can be achieved using the AI. And I'm going to probably show you some of the use cases also that we have delivered in the Indian market scenario, so that people are able to associate and correlate their challenges, and also see that if that makes more interest to them. So going ahead next today, what we basically want to discuss is that what people have or the utilities have achieved so far. And next is to understand that are these solutions as a long-term reliable solution or not. Then is to see that what is available as an AI solution in terms of predictive analytics and maintenance. And then to understand that how it is best for the utilities either to decide should they build, buy, or do a partnership, and then enhance to get at the end to understand the return on investment. Because at the end of the day, whichever utility is trying to progress into the journey, they will have to justify this to the regulators as well as to their own management. So going ahead next, I would actually say that typically what is the current scenario? Currently, most utilities, to make that inspection faster, what they have done is that they have started to engage with drone companies, or they have their own drone system platforms. They're collecting data, but the challenge is that by looking at this data, which is mainly based on looking by human eye, it actually generates a very low to a very less amount of valuable information, because the key here is to understand that from the collected data, what is the valuable insights that the utilities are generating? Are they helping them to do proper maintenance and also help them to get more return on investment? So typically, when you look at these reports that you generate from the collected data, it first of all is not only time consuming, but also is prone to human error. And then, as you see here, many times by the time the report comes to the maintenance team, there is many a times that there are additional burden to the engineers as well as the linemen, because they have to see like lots of false flagging because wrongly reported things, or they are completely irrelevant in terms of the access. Once that has happened, they also still have to utilize multiple different software, as Ganesha was speaking, that people have to rely on different tools, etc. So it makes even things more complicated. So this is why it becomes quite a challenge. So we need to understand why this is coming and to see that what is the best solution that we can go. So as you see here, before I go on, I just wanted to give you some sample examples, like, when people engage with drone operators, they get some very rudimentary type of reports that makes things even more challenging, because there is not enough information about what needs to be done, how it needs to be done. So now we need to come and understand why a reliable solution is very important, because people have been jumping. Now, if you look at this particular presentation, what has been happening so far is that people have been engaging in the step 1 as drone data capture, and then directly jumping into the step 6, which is for the maintenance. So many of them have been skipping this entire, to have a long-term reliable solution, people have to engage into all these 1 to 7 steps. So that is why we've been focusing and telling that how this best is delivered to the utilities. And we have focused mainly the entire solution in the 4 quadrants, if you want to see. We divided that into a pre-maintenance task. Then the second is the predictive analytics, which comes as the brain of the entire solution, about how to generate the valuable information to make a decision. And then is to go for the during maintenance, about the engineers, how it will help the engineers to do the maintenance. And the last but not the least is the post-maintenance, about what has been done and how it can be done. But before jumping too much in depth, I would just say, yes, this part, data capture, is done and the sanitization is done. The critical part starts at this part, the brain behind this entire thing, because we have developed several multiple AI and machine learning proprietary algorithms that have been working on the huge database and the big data analytics to generate this. And this is where it becomes very interesting, because utilities are not just interested in finding that, okay, collected data and then start engaging their engineers to look into the fault. Utilities are expert in delivering the electricity from the point generated to the consumer and uninterrupted supply, and at a cheaper and a more affordable rate. So this is where our AI analytics comes to the play, and it helps to tell, first of all, what is the fault, where is the fault located, when is the best time to repair it, and how that can be repaired. Because to do this entire thing, also the budget requirement is there, because the budgets are quite restrictive. So you need to make very effective and efficient budget planning as the resource planning. And that's why the platform now generates an actionable item. And this actionable item directly gives the maintenance team, without needing to worry to start looking into the drone data and spend hours and multiple, like as a typical cycle of 167 days can be reduced to 25 days. And it tells exactly where, what, when, and how to repair. And then during the entire thing, it also tells the engineers of where and how to repair. And then it does a quality assurance saying that was the repair good? If not, then how they should move on. But adding to the same context in line with what Ganesh just was telling, that what typically goes on, like every utility has a bigger challenge that they need to decide upon should they build, should they buy, or should they partner. And this is where it becomes, this is a standard cycle, 5-year cycle for the innovation and development for the program. Now, if utilities have to engage into building their own solutions, firstly, not only it will engage into having this, they have to go for the all 5 years level from TRL3 till TRL9. They need to collect the information, what needs to be done. It becomes quite a different situation, and also it may not cover the entire aspect, and plus the intelligence is lost. So hence, where it becomes very interesting to see that, can you wait for next 5 years? Can you keep losing that? Plus, by the time you're still developing the other solutions which are already available, they start to progress and mature and keep giving better results and better outputs.
If I could request
as
you
see
to
here, this is the
speak, since we're unfortunately running behind time, if I could request you to move to the key points, if you could. Thank you.
Sure, I will just, sure, definitely. Thank you, Rahul. So what typically starts to go is that utilities need to decide upon if they have to build, buy, or partner. So when you see that entire thing, it depends upon the utilities that they have to have the urgency of being able to have a solution that helps their engineers to do a quick maintenance as well as to generate more value out of their resources. Because the entire thing is that what is the strategic priority? Are they able to wait for the next 5 years and lose the entire losses? So if you look into this entire thing, the automatic thing starts to come that rather than buying, because if you buy, it is a one-time thing you invest, but then the technology is constantly evolving. So you cannot have a better solution. So you have to rely on something which is constantly being evolving. So, and if you go for building, you need to have more skilled labor and within your own firm. And that is again takes much longer time. So that's why we always see that partnering up makes much easier approach for the utilities, because for us, it's also beneficial because we invest heavily in terms of the research and the development of the solutions that all utilities can get the value. Plus, it is cheaper for the utilities because we can divide the overall cost in multiple customers. So the volume of economics plays into, and it gets justifiable for the utilities to get more beneficial solution out of it. So if you see here, I've divided this entire two things. The key point behind is that if you're collecting the data or you're using drone, you're using IoT devices and whatnot, you're collecting huge amount of data. But then what do you do with that data? If you have to start gazing into the data, it takes typically from the inspection till budget planning, the resource planning, and the maintenance, and then post-maintenance. It is typically 167 days cycle. In that process, a small fault can become a major critical fault and sometimes even failure. So hence, this is why we talk about why it becomes very essential to have an AI platform. Now, the AI platform that is done, as I said, since it is catering all different customers all across the globe, it is constantly evolving and giving the solutions in terms of the better overall visualization with a higher accuracy. And also it helps the managers as well as the O&M heads to make a quicker decision so that they can make an optimized and efficient, cost-effective maintenance. And also it gives a better return on investment, not only for the operation and maintenance costs are reduced by up to 50%, but also it increases the asset life up to 20%, that is additional 7 years. So then that way the utilities actually benefit more from the solution. I will skip this part because this is more about the beneficials that, already when you know the health score of individual line and you know the exact information about your resource availability, etc., you're able to better utilize the extra time that you have saved and you're able to generate more value out of it as a customer. But this is some of the case studies that we delivered in India for both for the utilities in terms of the discoms, in terms of the transmission as well as the distribution companies. So this is to give you this scenario that when you're collecting things, if you're going to look by human eye, it is very difficult to identify different issues. But here within one simple data, very precisely and with higher accuracy, it delivers exactly where the fault is located, what needs to be fixed. And we provide that also with an augmented reality AR/VR goggle as well, so that the engineers are able to do very much quicker repair and maintenance. So for example, if you look at here, automatically the AI starts to identify where the fault has been missed. Okay, so there's a missing fuse that is there that needs to be replaced. So those things become much faster. The other examples, if you are still in the distribution business, I know that until 11 kV, you would have to go with HVDS system. But then if you are in anything above that, so 33 kV or 63 kV line that you're bringing in, where India starts to have much more complex thing because it is a quite congested area. So you can see that, simple issues like, sag, for instance, there a conductor cut, okay, or the issues in terms of the armor rod missing or the stranding of the cables, etc. So the human eye cannot see that instantly, but AI is able to go and detect, look how much even the variation well in advance, up to 6 months, to say, give you enough time to prepare yourself that what needs to be done. And also, if, for example, if there is a flashover, etc., it tells you to really give you a very precise information so that instead of losing the entire insulator string and then letting the entire line trip down, because when the line trips down, you need to understand that it is quite an expensive deal, because if you're carrying a, let's say 35 megawatt line, even in that switching of from L1 to L2, in that 5 minutes time, you would actually have already lost something close to 1.35 lakhs. So you can see that these things immediately are quite a significant chunk, because the revenue, the loss in revenue itself is quite significantly higher. So you can actually make better benefit out of it. And giving the scenario solutions, how AI definitely has been giving a better outcome to the utilities. So anyways, I will stop here and give the thing in terms of how our solutions are now not only across the globe, but also the Indian customers have been benefiting the solution. And we are happy to discuss with utility companies who are interested in generating more value from the process of the automation and use of AI to help them reduce the cost, and also to make it faster, because then it gives enough time for them to do a better pre-planning. So then there is no unplanned shutdown. And at the same time, by doing early preventive measurements, maintenance, you're able to save many-fold of the overall thing, because a small fault, if you fix early, it will cost you less time and less money. But if you let it to last longer and eventuality of failure, you would end up actually having a much higher loss of money as well as time. So thank you so much. And
thank you. 10-second question, very brief. Is there any special licensing required to run these drones? Because in India, drones are a regulated space.
Right. So very interesting.
Very quick answer only,
question,
please. Yeah.
Rahul. So what I would say is that, first of all, the concept of now flying the drones have become much easier. Now, flying drones, utilities can invest themselves. We actually promote our customers to buy their own drones as a capex investment to the regulators, because it is not, flying drones is not a challenge anymore, because now rules have become very simple. The laws have the DGCA has already given exemptions for the power utility use cases.
Okay. That's what I wanted to check.
Lower than 250 feet. Yeah.
Yeah. So now it's streamlined and different than as it was before. Good to confirm.
Exactly. So everybody now can see that, yeah, this is very streamlined, and now people know that they can just buy their own drones. Only thing that they have to focus now is that use of AI. So better is, as we said, like, using AI with partnering with AI companies makes it even better, because we can deliver solutions much faster. And also, since we have an upper edge of delivering the solutions, not only for India, but similar geographical locations, for example, in Saudi Arabia or Bangladesh, etc. So
AI deals with large data sets. The larger training you give, the better it'll be. So thank you very much, Ashutosh, and look forward to seeing more happening in this space in the coming years. We will hear more about AI and ML from other speakers, but now I would like to turn over to Viral Patel, who's the Vice President of Business Development and Sales at SenseHawk. Viral, you're there?
Yeah. Thanks, Rahul, for presenting the platform to showcase what collectively as an industry we can do in this space using technology. So just to have a counter on time, so how much? 10 minutes, or do you want me to change?
If you could shorten it, because we're well over and there's still 5 speakers left.
Sure.
So
yeah,
around 7 minutes, if you could.
Sure, definitely.
Appreciate that.
Yeah.
That'll give us time to interact and follow up on some key insights, maybe.
Definitely. So are you able to see my screen?
Full screen. Yep.
Yeah. Okay. So just a brief. SenseHawk Inc. Is a US company now present over 20 plus countries where we offer our solutions, with offices across 3 locations, which is US, UAE, and in India. We've touched across 100 plus customers, and essentially our solutions have been used and deployed mainly in the renewable energies domain, and that too specifically for solar photovoltaic. So we've touched across close to 45 plus gigawatt worth of assets, and how technology can work from project development to asset management stage is what I would focus on specifically.
Could you hit the hide button? Sorry to interrupt. There's a hide choice.
Yeah, sure.
Yeah, so we can see the rest. Yeah, thank you.
Yeah. Right. So I'll just jump straight into what we are specifically doing and where we found deep vacuum when we, so basically the birth of SENSOC was out of where we ex Sun Edison colleagues. Sun Edison was one of the world's largest renewable energy company, and we saw there were a lot of gaps in terms of the availability of the technology for basically any infrastructure asset, you may say. Solar photovoltaic was something that we understood the best. However, when these kinds of assets, when you have assets which are spread across multiple locations, and now invariably a lot of IPPs that you have which are spread across multi-geography, you do not have a complete enterprise asset life cycle management model, something which is very common, say, in factories, like you have an FMCG factory or a tire factory, where you have end-to-end control and visibility available, which in case of solar, it typically would start and end with SCADA, and you would basically bring that information of SCADA at the site level from to the head office, something like a network operation center and all, and that would essentially end the control over there. But as we move forward, specifically in terms of being able to understand solar photovoltaic better, because one of the key area was that most of these photovoltaic, either production as well as the core first science technology, is invariably in China, Taiwan, or in Southeast Asia predominantly. So it was very critical where we interact with different stakeholders, including lenders, including independent engineers, that you need to have. I mean, there is a lot of data which gets collected, but there is no way in which you can basically scrub that data, hold that data in a particular fashion, and then basically analyze and draw meaningful insights out of it. And that's where we saw that there is a deep vacuum in terms of having a complete single platform from the development to asset management stage. And in this particular platform, where drones, one of the kind of areas which is the most talked about, be it from industrial application to defense application, how we can make use of drones, IoT, and various other technologies and create it as a single platform for, right now, I would say qualified for photovoltaic, but we are basically seeing use cases and developing use cases across other infra domains, which is including highways, including thermal power plants, and various other assets. And what this would also further do is it integrates with your ERP systems, the classical ERP systems like SAP and Oracle, which basically completely ties across the entire, from the risk to management to the auditing perspective to end-to-end change. And that's why we basically call it as more like an operating system that you need for an entire solar assets. So these are some of the use cases which we have developed, drones being one of them, right? Exactly as Ashutosh spoke about, that drone just not use it as an instrumentation device to just collect images. However, you need to draw meaningful insights and analytics out of it, based on which you can basically further draw a lot of conclusion, because otherwise it's just you are removing one part of, or easing one part of a data collection, which is a very in terms of the hierarchy or the order of technology adoption, it's at a very base level. So what you need to do is you need to create algorithms which can specifically detect and give actions or insights to the actual, say, patrolling guy or linesman. So across this, the core architecture, which I would say the entire platform is essentially a GIS based architecture, which again, we are seeing the penetration of GIS technologies across the domain, like day to day, that we end up using, say, a ride hailing cab like Uber and Ola. The entire backbone is GIS, how you can make use of satellites and maps and completely initiate your transportation, your mobility, the same way, to be able to tap into the power of GIS for the assets which are specifically spread out and wide. So that's one another very key technology layer which our platform basically enables. Based on these, all the other activities in terms of having complete document management, instead of just using a cloud repository like a Google or an AWS, how you can basically tag and manage documents based on asset level information, task management, and digital forms, to basically eliminate any paperwork like creating forms, checklists, fields, and which just basically lies as a part of the filing. So instead of that, how you can have a common database which goes through across your GIS layer, your drone data, your tasks, your activities, your electrical parameters, which would come in from SCADA, the CMMS, computerized maintenance management systems, which would basically initiate further tasks and activities. So this is where the envision a complete whole operating system for any asset. So these are some of the use cases that we have developed and being used across the wide variety of spectrum. One is usage of new sensors and sensing platform like drones. So using drones, the currently what we are basically doing, having few of the application areas is how you can map the entire terrain and the assets for topography, for hydrology analysis, and analyzing the climate change parameters in terms of risks from the rainfall, drainage analysis, and those. So that is one of the strong use cases at a project development stage. Then, so I'm not going through the detailed case studies here, but these are some of the case studies which where we have worked, where even after a plant is built, to be able to understand and assess the flood and the risks management associated with respect to the plant. Then how you can basically improve your construction stage, how different elements of constructions which are happening. So instead of having typically your PMC which goes and does a sampling basis, you have an en masse site inspection going down to each and every element of constructions, right from roads, trenches, piles, posts, modules, all the areas. I would say classify or disclaimer over here that the elements which are above ground level. These are some of the quality inspections that you specifically you can do with a high resolution imagery, that in terms of detecting any errors, detecting how the quality of the work is done with respect to the designed layers which is there. Then you usage of drones for inspecting the module health checkup, that how many amount of modules which are impacted. Then based on that, we have developed our own
So one
algorithm.
drone can do 100,000 solar panels per day.
That's right, 40 megawatts approximately. Now,
One drone, a
depending single drone, correct.
Wow.
So yeah, so this might further start going up, because now these days you have 500, 550 watt peak as a single module capacity, right? So yeah. So based on thermal imaging is again where we have developed the AI algorithm completely similar to what Ashutosh was sharing, which then classifies and goes through each and every pixel based data to identify what is the cause of these hotspots, say issues related to diodes, issues related to string, whether these hotspots are because of cracks, hardware failure, whether these hotspots are because of dirt, dust, because of PID. So various different classifications. So this serves as a very good dipstick in terms of your first L1 investigation as to where the underperformance or the plant is malfunctioning, and then to basically do a further deep dive of the causes, or to invoke warranty, you can basically do L2 level of investigations, which again there are a few companies which have explored doing EL and flash using drones. So you can have a lot of these
If I
diagnostic
could ask you
tests.
to, sorry, 1 minute
Sure.
to come to the concluding points, please.
Okay, sure.
Yeah.
So
Thank
yeah, so basically, I would just be concluding in some of the use cases and the that we have developed is, like you said, the drones and the sensing platforms across the life cycle of the asset. Then basically combining this drone data with the SCADA data, so that the thermal parameters that you see and sense, and when they are correlated with the electrical parameters, you can draw much more meaningful insights about it. Then the digital twin, which again a lot of industries like aerospace and those tapping into each and every finer component to understand the behavior and schematics of that, how you can basically tap into power of digital twin for better asset management, digitizing site O&M, classical digital transformation which every industries are going through. So that's one of the use cases out over there, with so much amount of being data collected. It will basically streamline and harmonize a lot of your site operations for effectively helping you improve your top line by ensuring better and improved enhancement in generation. Integrations of a lot of these ML workflow models which are developed across the use cases, and then basically mobile first. So a lot of these tools are developed such a way that the site engineers, it basically motivates and site engineers to do it instead of having to fill form, paper checklists, or a lot of data which does not get captured. In this case, they collect images or pictures or videos, and all these parsing of the algorithm, these data gets parsed through the algorithms, and then meaningful insights are driven through that. So yeah.
Thank you very much, Viral. Very complimentary presentation, I would think, from the previous one. So, and these were Indian use cases you focused on too.
No, so these are across, like Pip said, we worked
But
across 20
solar, I
plus
mean, of course,
countries.
solar is very
Solar
big in
is
India. Solar is a
correct.
very big deal in India. So this is
Yeah, but
definitely.
we've been working across I mean, all these deployments have been across from Australia, even to Japan, Southeast Asia, Africa, countries right from Morocco, Egypt, South Africa, South America,
Global. I
US.
mean, yes,
Correct.
global.
Yeah.
Yeah.
Because the scale, the instrumentation as a device, as well as digitization, right? In fact, in India, you have still the availability of trained manpower and manpower available to go there at the site. And when you take these use cases globally, the availability of the manpower as well as the price pressures to do an asset management within a certain price target, you need to have digital solutions to be enabled to
You
do
need
that.
to enhance the manpower skills with technology.
Yeah.
Yes, absolutely. Thank you, Viral. I would now turn over and request we would now like to hear about grid edge solutions for Indian discoms, and I'm going to go on a limb and just say that this is the edge of the grid is one definition of grid edge, but maybe we'll hear more nuance. And if I could invite Greg Myers, who's the Vice President Product Development of Trilliant Networks.
Good morning, good afternoon, and thank you very much for this opportunity to speak with you today.
Yes, your content is loading. If I could request you to focus more on the key points and less on some of the details, that would be helpful.
Yes, I'll hit those in the beginning.
If you could full screen it, yes, thank you.
There we go. Great. I'll get right into it. So Trilliant is a connectivity company, and we provide infrastructure solutions that enable actionable intelligence utilizing open and secure communications platform. And we believe that moving forward, in order to go from Smart Grid 1.0 to Smart Grid 2.0, you're going to need the need for frictionless exchange of data has become even more critical. And what we see in all of the different, we're deployed around the world. I'll show you a little bit about that, but we believe that it requires a hybrid wireless communication network. Legacy Smart Grid 1.0 systems were proprietary. They were one technology, and ended up only lending themselves to being able to do metering versus being able to branch into everything you need to do from an AMI Smart Grid 2.0 perspective. Okay, and so this is what I'm talking about as far as the different technologies and where they would be used at. You would utilize secure, we call it secure mesh, but a meshing network to be able to, from a wide areas perspective, be able to get the low latency, the high bandwidth type of applications and connecting. We see that as a grid, as being able to connect things, devices on the grid and so forth. And then we have the NAN, the secure mesh neighborhood area, which is really for your low, for your devices that aren't necessarily high in bandwidth, but they are in mass deployment, like your normal AMI type of deployment. And then we see cellular as an augmentation to those for being able to provide in maybe some hard to reach areas and so forth, or where it makes sense from an OpEx perspective. And then lastly, a low power land secure reach that enables you to be able to penetrate those areas that are very difficult to be able to penetrate, as well as, again, some of the hard to reach areas that you're going to need to be able to have to prevent from having those holes in your network. And from there, well, the other thing we see is that to support the next generation is you're going to need to be able to not only do all of the things that Smart Grid 2.0 is requiring, which is moving from a one-way bulk transmission system, a generation and transmission system, to more of a neural network that has inputs coming from distributed energy resources that are peppered throughout your territory, service territory, and be able to connect all of those different things together into a single pane of glass to provide you with the intelligence and the controls to be able to do all of these different applications that you see on the left. On the right, you have a number of IoT types of applications. A lot of utilities aren't sure what their role in IoT is going to be beyond the standard utility use cases, but the network that you deploy ability, and it should be open enough to be able to expand into these different areas, as these things will eventually become tighter and tighter coupled over time. A little bit about Trilliant. We have 31 million plus endpoints that are deployed in 50 countries. Some of the ones that are closer or nearby, of course, EESL, meter OEMs, and to date we have 1.4 million meters installed with our communication in it. And then TNB Malaysia, we actually have 18 meter OEMs integrated and 1.8 million meters installed. And in both cases, the rollouts are continuing. That's just where we are from a status perspective right now. And then I have a few of the larger companies, the larger deployments listed here from around the world. To go along with the communications network, Trilliant made the decision that they wanted to also be able to provide a number of applications for the utility, and there are some utilities that will split all of those different things up, and there are other utilities that would like to be able to have a one-stop shop kind of thing. And for that, Trilliant acquired Primestone, which is a Chile company in Bogota that provides meter data collection, alarms, a lot of different analytics capabilities to enable Trilliant to be vertically integrated from the device all the way up to the application layer, so that when we're developing things at the device level, we take into account not only the communications network, but also the analytics that are going to go behind it. Ideally, you start with the benefits and you work your way down throughout the network, down to the end device on where you do what from a capability standpoint. And then all of the meter vendors that Primestone is currently integrated with, and they tout that they have been able to read any device, and right now they have over 300 meters that they have connection to. 300 types of meters they have connection to. And that was my last slide. I tried to go as quickly as I could.
Thank you very much, Greg, and I appreciate your speeding it up. I think you've covered, it's one of the things I'm seeing from you, met others as well, is it's not enough just to have one hardware or widget. It's really going up and down the chain that provides the value for the end users, if I understood correctly.
Yeah, that's right, and the flexibility, absolutely, because the use cases aren't just metering anymore.
No, there's a lot more potential, and I think we're barely scratching the surface. You showed a
Thank
lot
you.
towards smart cities and some other applications which are yet nascent.
Yeah, agree.
Thank you very much, Greg. If I could now turn to and request Vish Ganti, who is the Vice President and India lead at AutoGrid.
Well, glad to connect with you, and it's my pleasure to be part of the panel. And thank you so much. It's 5 o'clock in the morning for me in California, but
Oh, you're not in
bright and
India,
early.
sorry.
No, so yeah, I'm spending more time in the US as I'm handling most of the global product management practice at AutoGrid. So I do India as well as the overall product for the company. Awesome. Well, thanks so much. So I'm going to quickly not spend too much time on the technology and the product, but I want to really come at it from a more customer point of view as to what value does the grid edge provide from a customer standpoint. What, as a consumer, what can I tap into? How do I benefit from being part of this whole game, right? So far, we've heard a lot of perspectives from folks who come at it from either a technology provider or a utility, but we've always keep making the mistake of leaving the consumer behind, right? So the question really is, what's in it for the customer at the end of the day? If they're going to end up paying more bills, right? What's in it for them? Why are they actually part of this whole ecosystem, and how can you leverage them? I think that's actually a big factor of what I want to talk about today, and actually leave a lot of room for discussion, because there's a lot of exciting things that industry as an industry we can cover here today. So about 4 or 5 months ago, I did a quick survey within my own LinkedIn group, because I have a huge network of folks that in the industry, and the simple question I asked was, who owns the smart meter data, right? It's not the smart meter, but who owns the data? And the answer to that was very jarring. 60% of the folks actually came back and said the utility owns the data. And that's actually a point of contention itself. It's the actual consumer who owns the data. It's the utility who is the guardian of the data. They're just capturing and maintaining the data, but it's actually generated at the edge, and the consumer owns the data, which also means imperatively they should be empowered to share the data and use the data in whichever format they want, right? So case in point, and when we think about smart metering, are customers able to tap into the data, give a historical profile to solar installers, so they can actually predict exactly using their own data what is the size of system, what is the net impact on the bill that a system could provide, right? And today, and I see that as a jarring gap in India, right? So in the US and other markets, what these tech companies have done is enabled the customer to actually go and click and say, here are the partners I want to share the data with, and they can choose who they want, whether it's a DR provider, whether it's for a solar storage, any other use case, right? Or even insurance use cases that we're seeing now, where data can be shared for that. And I think in India, that's really the biggest barrier which needs to be solved, is at a very early stage, how can we put the foundational bricks in place that allows these customers to share the data with a bunch of different, to enable other use cases to emerge on top of it, right? So this is a data fabric that we're building, and I think we need to socialize the benefits of this data as a whole. And as I say, individually, there is some value, but as a whole, as a network, I think the value increases exponentially. When you understand the usage patterns, when you can segment the customers and kind of target based on various parameters, right? So speaking of that, we've done a pilot in Tata Power this year in Delhi, where we ran a small pilot, and we just basically studied, we recruited about 2,000 customers to be part of this pilot. And during certain times of the day, during peak hours, or even in the nights, in the evenings, we just notified them and said, hey, go shave some energy or reduce some energy, and we'll give you some incentives. But oh, by the way, you'll also qualify for some lottery tickets. Like we will do some lotteries of smart home products, etc. But by reducing energy consumption, you will qualify to be part of this program, and you can earn rewards and actually reduce the cost in your bill, right? This same exact model we've deployed in about 5 other countries, and we're deploying it at scale for about 3 million customers in Hong Kong this summer, right? And the reason, and the ultimate underpinning reason for all of this is we want to reduce the dependency on fossil-based generation, even though we have access to them. The point is, if you want to decarbonize your supply chain, you need to start reducing the dependency on thermal power plants and fossil-based generation assets, and start making that shift towards cleaner technologies. So by tapping into the data, as we talked about from all these sessions, and allowing consumers to basically share with other partners, you can really create an economy where it's almost like Uberization. Uber knows what how many drivers are there in an area. Uber also knows how many riders are in an area, and they're basically providing that balance on both market side as well as on the customer side. And I think the real value is, as a customer, we start to save money at the end of the day. We're paying much less than what we would otherwise, taking a cab from a non-Uber type business, right? So that Uberization model has intrinsic value, and we are actually untapping or leaving it untapped in the Indian context. So I think from my perspective, I want to see policy and mandates that push us more closer towards data and how we can tap into the data. And also the business cases have to be very, very crystal clear that when you put a capex into a particular, let's say, an EMI deployment, how are you recovering the cost? Because in the first 2 years, you might see a very good return, but year 3 onwards, it starts to become really difficult because the low-hanging fruit has been plucked, and the rest can only be actually brought into the mix if you start engaging the customers and start introducing them into how this data can be leveraged. So yeah, I mean, I don't want to spend too much time with slides, but I thought it's really important to hit the nail on the head with the customer being the focus.
Thank you. The bank robber, Willie Sutton, was asked, why do you rob banks? Well, that's where the money is. Well, the customers are where the money is and where the focus should be to empower them. In India, of course, PDP, the Personal Data Protection Bill, is still pending. So that should hopefully give some more teeth to the ownership question. That's nebulous, like you said. It's worldwide, it's different utilities, and others view it differently. My 10-second question to you. Let's assume you get data that shows how a customer could save money, put up solar, reduce fossil, and so forth. To what extent is there pushback or resistance due to things equivalent to the utility death spiral? Do you see that as a problem? I mean,
Well,
data, how much would it be a zero-sum game?
So that's where, I mean, it is not, because what's really happening around the world is you have these data providers, utility becomes a data provider, but there are retailers that actually go to market and own the customer, they own the relationship. The retailers just use the meters as if it's just a piece of infrastructure to stream the data, right? So this was repeated in the telecom sector in the 90s, and when the cell phones actually started to become more prominent. You have this, BSNL actually operating the backbone of the telecom network, but you have Airtel and Vodafone and other companies which we emerged on top. And those are the guys who went and recruited the customers and had discounts and plans. That separation is actually what we're seeing is a massive transformation in the global industry. In Australia, it's happening in California, Texas. So the retail energy market that is evolving is going to push so much competition down that the utility ends up becoming poles and wires and meters company at the end of the day.
Yep. Thank you. No, I think more choice, more competition will happen, but we're not quite there yet for social welfare redistribution and other issues in India. It's a longer conversation, but it's inevitable, and technology is just accelerating it, I think. So.
Yeah, and I think social equity, when you think about smart grid and all of these things, do not actually surface a lot. But you kind of really touched upon it by asking earlier about rural versus urban, right? Because I think the marginalization of these customers in different segments will be seen a lot more in a stark way here than ever before.
Absolutely. It's the CNI who are going to be early adopters for a lot of these technologies. So thank you, Vish. Good catching up with you, and thank you for the very insightful and consumer-centric remarks.
Sure.
We'll now come to the last subsection, where we have experts really talking about the applications of machine learning and AI in consumer data analytics, and of course something very key for India, which is also theft detection. If I could first request Sabyasachi Patnaik, who's the director with Oracle, of course one of the leading, well, I wouldn't say database companies. That's the old way of remembering Oracle. Yes, I'm that old, but really much more than just databases, but the entire ecosystem on data handling, data management. Sabyasachi.
Thank you. Thank you, Rahul. Good to see you here. Now- and yeah, I'll pick from where Vish has started, and it gave me the right platform to talk about. So very quickly, as I know we are behind the schedule, so I'll try to be as crisp as possible, just for the I'll give a brief about what we are, who we are, and what we do, and as you have mentioned about, these are all few numbers, but one takeaway from this slide is the number of meter reads which we have. Uh, while we know that, and we are doing a little less on the the end consumer whose smart meter data we are talking about. We are doing a little less for them, but what should be the lingo, what should be the communication kind, what will trigger their action, is one which is which we at OPA focuses at. And with the maximum number of meter reads, we can synthesize, analyze, and go to the customer or consumer with their with the tips, and with the with the right message which the utility wants to share, and make the consumer as partner. Involve them in any of the program. And the best is our program, which we can as I've talked about, is an opt-out, which is which is scalable, which is equitable, very highly across the utility, multipliable, pliable, and use both the smart meter data, and the basic part is the behavioral science, which is we have been using. We have scientists who works on it, and you might be knowing this is a publishing house of US who have rated us the best in the smart meter analytics solution for the residential. So what we do is the solutions which we focuses are on the residential segment, which, as you very rightly said, that the low hanging fruit and every for the right away, having the POC and the pilot done and get the best results. CNI is the segment which everyone targets for, but we at OPAR Oracle works on the residential part to it, which is a little neglected. So, but what we do here. So we are an AMI centric strategy, which we provide consumer, the end consumer, the residential consumer, and then we make them as a journey when they start having the meter right from the beginning. When they get the meter, the smart meter installed, right from there, how they need to be aware of what they should expect and in what way, and of course, in a simpler manner. There is a study by Accenture which says a normal consumer spends about less than 9 minutes in the whole year to talk about, or viewing or thinking about their energy consumption, or energy services provider. So in a one way, we have this limited window of 9 minutes, which we have to be really prudent in what we are sending, and how we can make them a partner and call for action for the consumer. At the same time, we have to be also, if we can, increase this duration from 9 minutes to maybe 9.25, 9.5 minutes, or maybe 10 minutes. That's the way. So what we do here is we have talked about a lot of data which comes out in every 15 minutes, maybe 30 minutes. So, as a human mind, what we have seen, our uh, behavioral scientists have seen, is that generally the human mind takes up a shortcut, and which is generally kind of is correct in a way when they take a action when there is a lot of situation, a lot of data which is coming on. What we do is what we specialize in doing that with this particular data which we find it from the utility, get it from the utility smart meters, and from the consumer smart meters, we simplify it. This complex data, we simplify it, and we try to communicate with the consumer with the language which, or kind of or the symbols which he or she understands, and of course predicts and offer each consumer needs, that we target. So that's if it is, when I say each customer targets, I meant is when there is a smart meter installation, then there would be the messaging would be different, as a welcome to the world of smart meters, something that sort, not exactly. But now with during the smart meter installment, if we have a solar installation, rooftop solar or EV, then the messaging is different. Then the hand holding, or then the education for these application, and it is different for each of the consumers, and for each of these solutions which they take up. And it's the same platform which can be used for all the actions from the consumers, and where this is what we use the deep machine learning and artificial intelligence to communicate with the consumer through the utility. And that's these are the few proven principles of behavioral science which we use. And these 2.5 trillion meter data which I have talked about helps in targeting. So what we do is these are the 3 steps for any, this is a few instances which we have seen in US. But if we come to India, these are the 3 stages of smart meter investment. What a utility tries to do is that we educate, engage, and innovate. I mean, that's how we handhold the customers when AMI meters are there. Different educational program, whether it is whenever it is TOD, then TOD, or any other peak time rebate, or demand response program. Similarly, engage with them in events like demand response or customer engagement home energy tool. It's so that these are the engagement. And of course the third is about innovate, which we can scale through many other so this is what we feel with the data which we do and which we communicate through the utility. This would be a a 3-step, as I said, that educate, engage, and innovate. And this is a scalable this particular platform can be used in multiple marketplace generation, and ultimately it is a path towards digitization for the utility, for the customer and through customer engagement. And that's what we have been doing a few things pioneering. So we have started our educational report way back in 2017 in US, and few other things which we have done. We are working on ASI integration, but in
How many of those are in India?
So we have educational report, we have behavioral loads shaping is very soon would be there, and then home energy reports are there, digital self-services are there. So these couple of them which you can see in this frame, out of 7, we have 4 of them are already there in India, which we are ready to include. And then that's there is. So in the last, this is what we have achieved so far. So from the home energy reports, behavioral energy efficiency, we have saved from the residential segment 31 terawatt hour till date. And we have from the behavioral demand response in various events across US, it is 415 megawatt which we have saved. And of course, because of the opt-out, our scalability is 2 times more faster, and and this is what 165 millions of digital self-services which is there, which will ultimate has an customer satisfaction index, which is not so important as of date, but yes, this is a very, very critical thing, and which we have achieved, and we are trying to do that same in the country. So that's in a brief way and these are few other and one more thing which I wanted to stress upon. The same platform can be used for both AMI and non-AMI, and we have proven it here in the country with non-AMI and AMI also. We are trying to do that. So you can see this is like, home energy reports or web energy management, digital energy report, or like, high bill alerts, AMI educational reports, or WAMI, which we called as a weekly AMI report. So these are the kind of things, offerings, which is we derive through the use of AI and ML and behavioral science to it. So that's kind of, these are omni-channel communication cornerstones for the programs, which is very, very much there. And that's up. So yeah, ready for any of those questions or discussion points. If that is,
Thank
yeah,
you, Sabyasachi. Um, it was great to hear on the consumer behavioral side of it, because it's not just rational economics per se, but incentive structures which vary across consumers. And the Indian consumer is stereotyped as being price sensitive. Kitna deti hai, the mileage is sort of.
Absolutely, yeah, that's
But
correct.
I would hope and I believe, and just my 10-second question to you, I think that there's more than that. Yes, people remain price sensitive, but there's other aspirations, whether it's green, convenience, coolness, integration with other new services. I think we're going to see, or are starting to see that. Is that already there?
Absolutely. You have really raised a very, very important question, which I wanted to kind of address. Yes, not only the cost sensitiveness. Yes, definitely we are cost conscious, but optimizing the things. And the other is like, the behavioral science, what we apply, and peer-to-peer comparison. It's not about only money saving. It is about how best we can be. Like, a place like Vasant Kunj or Vasant Vihar in Delhi, they are not really kind of, conscious of how much is the electricity bill. But yes, sometimes something triggers is terms of like, being in the top, or maybe the best performing. So these are things, and engaging, like, like the way the thing is, the engagement in terms of all strata of the society, and we are customizing it, localizing it. We are communicating in Hindi, we are communicating in English as well. So that triggers, like, like a telecom operator or a credit card. So they never want you to swipe less, but still there is a alert which comes in saying that, hey, you have exhausted 50% of your data or 50% of your credit limit. Like, that doesn't mean that you
You
should
engage
stop
them. Yeah.
shopping. But that behavioral science, that nudge, that message really works. Kind of, that engagement really brings close the customer to the utility. That is, which is very, very important. And when we are talking about content and carrier, so these customer engagement will really play a very, very vital role in days to come, isn't it?
Absolutely. And of course, in Delhi, you've got a unique incentive structure, because if you're less than 400 kilowatt hours a month, you get an enormous subsidy from the government. So,
Yeah, up to
of course,
200, no bill.
no
Yeah,
bill.
up to
Yes. So
200,
that's an
no bill.
outlier in India, not necessarily to be replicated.
Yeah, I
But
know. Yeah.
there's many ways to engage with customers. So thank you for sharing your presentation.
Thank you. Thank you.
So
Thanks a lot.
I'm glad we had a chance to engage, to learn from the experts in the panel, and to also have a little bit of discussion. But we are over time. I'll just summarize or sum up in 2 key points or takeaways that I had before I hand over. One is that I think it's extremely heartening that this stuff is not just theory. It's not futuristic. It's now, it's real, and there's value proposition already available, and it'll only improve over time. The second point is it's always going to take effort and be a work in progress, because it takes a lot of complexity to make things simple. There's that old, joke. I wrote you a 5-page letter. I was going to write you a 1-page letter, but I didn't have the time. And so handling the data, harnessing the data is things where we want more technology, but of a different kind, to really bring the value proposition. So thank you again, everyone. And now I'll turn over to Reggie or the other organizers. Thank you.
Thank you very much, Rahul, and all the expert speakers who presented on various technologies and programs happening under mutual collaboration with US agencies. Now we will move on to the next session. I would request Mr. Ganesh Srinivasan to chair that.
So before that, if we can have a quick snapshot of a group picture of the speakers and the moderators.
Everybody, please turn on your cameras and we will have a group picture.
Next time, Aishwarya, maybe we should do it in the beginning because a few people had to leave.
Yeah, sorry about that.
No apologies necessary, just a thought.
Smile, and we hope next time we will be able to physically take picture like we used to do in the past pre-COVID days. Stand everybody together and take picture.
BC, before COVID, yes.
Thank you, sir. Thank you, everyone, for joining.
So, Parul, over to you. Please invite the chair and moderator. Oh, Girish is also there, plus moderator for the next session.
Yes, sir. So, with those remarks by Rahul, sir, we'll swiftly move to our next session, which is the future of energy storage in India. And for the special address, I would like to invite once again Miss Jing Liu, Commercial Officer, U.S. Department of Commerce, to the stage. Over to you, ma'am.
Thank you very much. I am back, and we are convening to discuss the future of energy storage in India, a critically important topic. As India aims to meet 50% of its energy requirements for renewable energy sources by 2030, the market for energy storage is poised to grow. In fact, industry estimates that Indian energy storage market will rise at a calculated average growth rate of approximately 10% from 2021 to 2026. Energy storage solutions can play a critical role in ensuring round-the-clock power by addressing intermittency issues associated with wind and solar, addressing smooth integration of renewable energy power into the grid, meeting the electricity demand during peak times, maintaining grid resilience, especially in the wake of increasing natural disasters aggravated by climate change. The challenge with energy storage is lack of commercially and technologically viable solutions, and it's encouraging to see that the government of India is making concerted efforts on the policy and regulatory fronts to incentivize the sector. US companies are keen to leverage the growing energy storage market in India. For example, Virginia-based Fluence set up India's first grid-scale energy storage project with Tata Power Delhi Distribution in 2019. And my office works closely with US energy storage companies like Fluence, focusing on opportunities in India, and you will hear from some of them shortly. And also, as you heard earlier, the US Department of Commerce promotes partnerships between US and Indian companies. For example, in the fall of September 2022, my office will take a delegation of decision makers from Indian companies to the US Department of Commerce certified trade event Solar Power International in California. This event sees strong participation from US energy storage companies, and during the visit, we will organize roundtables to highlight opportunities in India and facilitate business discussions between US and Indian companies. The US Department of Commerce, through the US National Institute of Standards and Technology, also works with the Government of India to convene policymakers and industry for cooperative exchanges on standards development through a standards working group under the US-India Commercial Dialogue. We also actively work with Indian trade associations like the India Smart Grid Forum to raise bilateral industry concerns and asks for the consideration of the government. I look forward to the focused and engaging discussions today in this panel, and I invite Mr. Rish Gatikar to moderate the technical part of the panel discussion. Over to you, Rish.
So much. Can you hear me?
Yes, sir.
Yes,
You
Rish,
can
we
hear
can.
me, right?
Absolutely.
Wonderful. Thank you so much. Thank you, Jinglu. Really appreciate those insights. Some great points on the value of the energy storage. I'm Rish Kadikar. I'm the advisor to India Smart Grid Forum. I'm also, based here in the United States. I work in the whole area of electrification, decarbonization, for a long time in my career, where I kind of led the integration group at the Lawrence Berkeley National Lab, which is the U.S. Department of Energy National Lab. Worked with Electric Power Research Institute, EPRI, which is an electric utility nonprofit organization. I work with private sector. I also now work with, big corporations and electric utilities in providing them with advice on electrification and decarbonization strategy. Companies like General Motors, for example, and large electric utilities based here in the United States. And I certainly look forward to having one of the very good panelists, a set of experts that kind of constitute the knowledge in the US of what's happening with the energy storage space in the United States. At the same time, we also have folks who represent some of the knowledge and the context relative to India. So why energy storage topic, right? You heard about the AMI, or automated metering or smart metering, as we call it in the beginning. Energy storage is a very integral part of India's energy security, okay? A lot of people look at from just, decarbonization, right? But I do also see that from the energy security perspective. So when you look about energy security, we're talking about generating locally, right? And being dependent on energy or locally generated energy source. Energy storage plays a very critical role in decarbonization. We all understand that. But energy storage also plays a very critical action in the climate action, right? The climate change, because of its inextricable link to two very important large carbon emission sectors. That's one is the electricity generation. The second one is in the transportation sector. In the electric generation sector, as Jinglu mentioned, India has a very aggressive goal of 50% renewables by 2030. So that's fantastic, great news. At the same time, we all understand through international experience, whether we've seen it in Europe or United States, that renewables add a lot of variability, and we have to address that variability in renewables. Energy storage provides a significant opportunity to address that. The second aspect of it is resiliency, right? The resiliency theme of how do we address a very large scale event or even smaller events becoming more and more important. And when we talk about resiliency, I was born in India, and I was grew up in India, and I understand, in India, resiliency comes by default in a lot of homes and buildings. And we call them, from the perspective of resiliency, we call them as, diesel generators or inverters with the lead acid batteries. The question is, how do you translate resiliency in a renewable, in a non-fossil manner becomes very critical. The last is the transportation. As we grow our transportation or decarbonize our transportation sector, the energy storage, especially the battery energy storage, the lithium-ion battery energy storage, becomes very critical. So the link of the energy storage is so important in the decarbonization electrification strategy that it cannot be ignored. So this panel today is going to specifically focus on how some of the companies and how some of the electric utilities are engaging energy storage to address some of those key issues. So before we go into the panelists and I introduce the panelists, I will call upon each one of them. They will provide prepared remarks, and we also have some questions that are targeted towards providing a very contextual representation of how the experiences in the US can be made relevant to Indian applications. And I'll introduce the speakers and we'll go through those prepared remarks. But before that, I would like to call upon Raghav Upadhyay from US-India Business Council to provide a special address. Over to you, Raghav.
Thank you so much, Rish. It's so wonderful to be here with you. Thank you, Jing, Rennie, and all my colleagues at the US Embassy in India. We're delighted to co-organize this session with the US Department of Commerce, USAID, DOE, and the India Smart Grid Forum for the second year. Thank you for having us here, Mr. Reji Kumar and Ms. Reena Suri. The USIBC has worked with government and industry across multiple parts, including energy and infrastructure, for the last 47 years. As part of the strategic clean energy partnership between both countries, which is why we're having this workshop, USIBC co-chairs a subcommittee on markets and regulation in the US-India Low Emissions Gas Task Force, with the petroleum regulator in India. In addition, we also interact with the US Embassy to organize industry initiatives when a dignitary from the US comes to India and vice versa. We did so with US Special Envoy for Climate John Kerry last year. We're really looking forward to the deliberations today in energy storage, given the fact that, we already discussed how important it is. Our members, including General Electric, Tata Group of companies who are here, ExxonMobil, Shell, BP, Reliance, Adani Group, Jacobs, Black & Veatch, a lot of these wonderful members who announced their own decarbonization commitments, are at the forefront of research and implementation of new technologies to help the world meet its climate commitments. So, like Jing had said, it is very encouraging to see India take steps to incentivize energy storage. We've got a policy clarification from MOP for energy storage just recently. We also have a policy in green hydrogen. So I think these are great steps, and we are moving in the right direction. We look forward to deliberations today by the eminent panel, led by Mr. Srinivasan and Mr. Ghatikar. Thank you so much, Rish and Ganesh, for joining us. We plan to discuss technology and policy priorities and deepen US-India collaboration. That's our objective, to advance decarbonization, electrification, and energy storage, factoring in costs and tariffs to keep viability of implementation in mind. We welcome you all to this session again and encourage you to reach out to all of us and to the speakers if you have queries or suggestions. Over to you, Rish.
Thank you so much. Excellent some updates in terms of the policy in energy storage, including some green hydrogen.
Girish,
That's a very important. Yeah.
Good morning. So we'll start with the opening remarks by the session chairman, Mr. Ganesh Srinivasan.
Great. Yeah, I was about to introduce Mr. Ganesh Srinivasan. So yes, thank you, Mr. Ganesh Srinivasan. He's the chair of the panel and session today. So, opening remarks from you, Mr. Ganesh. Over to you.
Thank you. Thank you, Rish. Thank you, Reggie. Thank you, Raghav, for the opportunity to address. The role of, or the importance of storage is quite obvious. I think there's not much that needs to be talked about further on that. Currently, of course, India has quite a minuscule amount of storage, about 20 megawatts of installed capacity and across various projects. Of course, 10 megawatt of that is with Tata Power in collaboration with AES, Fluence, and Mitsubishi. So glad to be part of that, and Paramita will be speaking more about that during the panel. CA has also projected that India will need at least about 27-30 gigawatts of storage by 2030. So the path ahead is also reasonably clear, but there are multiple questions. I think as a practitioner, I am really looking forward to this session because there are so many variables involved in storage that you pick up, and the field is also evolving so fast. Whether it is the multiple storage technologies, where would storage be most effective, whether it's generation, transmission, distribution, or behind the meter, and most importantly, how will they be funded? What should be the evaluation criteria, and what sort of regulations will really spur the growth of storage, particularly for state regulators to take that call to invest in storage. So I really look forward to this session. It's a very, very critical one, and look forward to greater collaboration between Indian and American companies. Thank you very much for the opportunity to address.
Excellent. Thank you, Mr. Ganesh. We really appreciate those insights. Fantastic points in terms of the front of the meter and behind the meter energy storage. Very subtle, but an important point we miss about energy storage when we talk about, it's not just about what happens behind the meter. It also happens, important to understand what happens in front of the meter, and different energy technologies can play a very critical role depending on the purpose that they serve. So fantastic. Thank you. With that, I think we will get to the main part of the session from our panelists and speakers we have today. We have an amazing amount of experienced panelists, some preeminent experts in the subject matter from both countries representing. I'll quickly name those 4 panelists that we have for the workshop today, and I will introduce each one of them. I'll introduce and call upon them to provide prepared remarks. The first one we have is Brian Shelby from GE Renewable Energy. Brian is the General Manager of Hydro Asia at GE Renewable Energy. Welcome, Brian. Thank you for having you here.
Thank you, Rish, and thank you to the panel and to the attendees for today's meeting. It's a real pleasure to discuss with you a topic that GE Hydro has spent a lot of time focused on. And really, it's kind of a good news, great news situation, both for pump storage hydro, which offers a massive amount of energy storage in less than 60 seconds, as well as for the country of India, which is going to require this type of large-scale energy storage capacity in a relatively short amount of time. So if you think about it, the technology is available today and can be deployed today against either greenfield sites or brownfield sites that exist in India. However, there are some practical challenges that have to be dealt with, and they need to be dealt with quickly in order for this industry to proceed, and more importantly, in order for the government of India to support its own goals to enlarge its renewable energy portfolio to, say, 450 gigawatts plus by 2030. Again, you can't get there without massive amounts of storage, and pumped storage hydro is the only technology available today and likely for the foreseeable future that is technically ready and capable to provide that level of support to the grid as the government moves its portfolio to renewable. So inside India, there's 5 watts of pump storage across 10 plants, half of still in mode, so generation mode. So if you look at the need of 30, 50 gigawatts of power, of capacity power by 2030, there's a massive opportunity. So how does this country go about addressing and really spurring on the development and getting shovels in the ground and getting plants built? Well, there are 4 real things you need to consider. One, the government needs to stand up and say, pump storage is going to be a major building block and foundational element for this market. If you look at your neighbor China, the government late last year decided that pump storage is a foundational element to support its energy transition to renewables, and basically said in the next 10 years, we will adopt and we will build 180 gigawatts of pump storage power. They've had a policy, they've empowered the market to bidding and start new facilities. Second, you need to consider how do you simplify and streamline the permits. Normally, the pump storage facility, it takes roughly about 3 to 4 years, depending upon the size and the geography. So if you've got a 3, 5, 10-year permitting process, you're talking about a massively long amount of time that a developer has to front a lot of capex and a lot of financing before you actually start generating electrons to the grid. Third, you need to create a financial marketplace that incentivizes and makes a commercial viability for these type of projects. That means thinking about tariffs and how do you value grid ancillary services and how do people then monetize their investment in these very expensive processes. Finally, you need to talk about how do you create a financial arrangements, banking systems, and support mechanisms to support the diversity of space. Like every large capital investment project, it's going to take a while before these start to generate real cash returns, and therefore you need a lot of capital to tide people over to get these things done. Think about it finally, significant amount of existing installed base in hydro in India that could potentially be repurposed in order to create new pump storage capacity. so you don't have to actually go build a brand new plant, a brand new dam. You can actually reconsider how to use your existing cascade of hydro dams on an existing river and recreate that opportunity into a pump storage. So with that, I'll stop and turn it back to the panel for further discussion. Thank you.
Excellent, Brian. Thank you so much for those insights. Great point on the potential capacity in India as a foundational block of using pump hydro storage versus what is really happening. So we'll get into that details once we get an overview from the other panelists. We really appreciate those insights. Learning from our previous session, I want to make sure that some of the session markers are leaving in a little while. I want to make sure everybody is around. So let's pause here for a minute and take a picture. If you could come on the camera, please, all the panelists and speakers. Okay, let me know when it's done.
It's done, sir. Thank you.
Wonderful, thank you. So we'll start with our second panelist for the day today. That's Mr. Yashwant Mahadevan. Yashwant is a director for sales for Asia Pacific as well as Middle East for another US company called EOS Energy Storage. Mr. Yashwant, is based in India and leads a lot of commercial activities for EOS Energy Storage in United States, Asia Pacific, as well as Middle East regions. He has over 8 years of experience in business development in the energy industry and has worked with many large companies in the past like Vestas, Siemens, etc. Mr. Yashwant also earned his MBA from Great Lakes Institute of Management and then has an electrical engineering degree from Sri Venkateswara College of Engineering in India. So with that, I would like to welcome Mr. Yashwant Mahadevan. Over to you, Yashwant, for your prepared remarks.
Yeah, thank you, Rish, and thank you everyone for this opportunity. I just have a small short presentation which I thought I'll share it with you and discuss on how we look at as the energy storage segmentation market. So if you look at 3-4 aspects of what we call
Yashwant,
it.
Sorry to interrupt. Can you put it in the presentation mode, please?
Yeah. Okay.
Yeah, thank you.
So if you look at 4 Ds, which are changing the entire world, right? Be it demand, be it decarbonization, democratization, and decentralization. And essentially, with the influx of renewables coming, we did discuss that there are 2 issues which are happening. 1, there is a wastage, and 2, there is a scarcity. We did see last year that in terms of what got wasted and in terms of scarcity, what happened in Texas, say, for example, in our cotton last year in the same time. So with this in mind, we feel that there is not a single technology which kind of fits all when it comes to energy storage. It kind of segments with the duration at which you would need to operate. So with this, we are talking about a short, which is somewhere between say 0 to 3 hours. Then we talk about a medium, which is an intraday, 3 to 12 hours. And then there is a long duration interday kind of a solution. And in this page, different segmentations have different customer needs. Customer needs in terms of a short being, say, high power and higher round trip efficiency. They would need to kind of respond to grid signals quickly in order to maintain the frequency balances. When you come to intraday, it's about flexibility. It's about simplicity in terms of how flexible you are in the way at which you operate. And of course, when you look at the long duration, it's all about what is the delta cost in terms of what you're going to add energy for the same storage. And typically that's where, and if you look at, there has been a series of new technologies which are coming in, companies which are coming in, which have been listed over here. And we have been in the journey over the last I would say 12 years, and in the last 2 years from a commercialization journey. So I represent EOS. EOS Energy Storage is a US-based company founded way back in 2008 with the option of just concentrating on the stationary energy storage side. And our technology is kind of optimized towards a 4R plus technology, and we operate anywhere from say 4R to 12R. The essence, when you look at what we did when we chose this chemistry, is we took inspiration from the zinc plating bath as an industry and also the flow chemistry, right, and made it as a static battery. So today you would have an advantages of what a static battery could offer, like a lithium, and secondly you would also have advantages of what a flow chemistry could offer, thereby with a longer duration, recyclability, non-flammability, and non-toxic all being possible. And the only reason it's possible is because of the fact that the product has been built with commodities. It doesn't have any earth conflict materials, and it's kind of scalable and safe as we speak. And the product is designed and manufactured in Pittsburgh in US, and that's where we are as a company. Just to give you a perspective in terms of how the company has evolved. The energy storage needs some time in terms of understanding the customer needs and then thereby kind of developing what is required to suit the customer need. And in this case, we have gone through the journey of close to say 10 years plus in the R&D phase, then the pilot phase, and now today we are in the commercial phase. So with that, in the commercial phase over the last 1 year, I think the company has been able to establish itself as a credible alternate to lithium, which is foreseen as a forerunner in terms of technology while providing energy storage. And this is kind of represented from our opportunity pipeline, from our order book, and we hope that this is going to continue. And what we have seen, it's not the US concentration alone. Of course, we have been doing projects in India. Of course, we are doing solar shifting projects for a couple of marquee developers here, some microgrid projects in Africa, then some in Greece. Essentially, if you look at the use cases, there are a variety of use cases what we could look at from both the FTM behind the meter as well as the front of the meter side over here. In essence, what do we see as a need today is an ability, specifically in India. If you look at what's happening, we would need to have an ability towards having multiple revenue streams. I think today we are getting there. We are getting there in terms of our first going to have an energy policy. Secondly, we did see CERC releasing ancillary services. Thirdly, we are starting to see larger bids now coming in. So hopefully with all these aspects, we would definitely, I'm encouraged to see that India would be one of the larger energy storage market. But eventually a lot of policies have to be formed in place in order for that to happen. And there has to be some sort of a support, which I feel. Yeah, thank you.
Thank you, Ashwant. Really appreciate those insights. So great point on the need for the short and long duration storage, right? Even here in the United States, we are not just looking at the short duration to address some of the intermittency we face at the wholesale level, right? The frequency regulation ancillary services market, but also looking from a long duration storage for at the grid scale. So fantastic point. Our next speaker is Mr. Randeep Singh. He's the Director of Electric Mobility, an area that's very close to my heart, and the area that I work extensively on at Niti Aayog, India. Mr. Randeep Singh has worked in the corporate sector before joining Niti Aayog for almost 12 years. And he is instrumental in bringing the light electric vehicle charging standards published in the mid-21. Again, data and interoperability is another area that was very close, that I work with. So I'm very heartened by the fact that he's working in those areas extensively. Mr. Randeep Singh is an electrical engineer from NIT and has an MBA from IIM Calcutta. Over to you, Mr. Randeep Singh, for your prepared remarks.
Thanks, Rish, and thank you for having me here. I'll quickly touch upon the points which I picked up from the energy storage perspective in the budget for financial year 22 announcements. So first point is about the data centers. So data centers, energy storage systems to be included in harmonized list of infra sectors. This will include dense charging infra and the grid scale systems. So what is the impact of this inclusion is going to have? This move will facilitate credit availability for digital infrastructure and clean energy storage. Remember, energy storage system as the one critical technology which needs innovation, finance, and the regulation has finally got the attention in the budget. As you are rightly aware about the advanced chemistry cell program, which we are trying to localize, through which we are going to try and localize the advanced cell manufacturing in India. This is a capital intensive process, and inclusion will open up several gates for the affordable financing with long term repayment tenures. I will talk about the advanced chemistry cell program, that is a battery storage program, further after a while. Further, charging infrastructure also needs this kind of support as very few fast charging EVSEs are manufactured in India, and finance is one big hurdle due to the fear of the technology obsolescence. Further, it is also mentioned in the budget spatial mobility zones for EVs, augmenting charging infrastructure, ratifying building bylaws. This, I think, is targeted to address the range anxiety part. Plus, it will also lead for the adoption of the EVs and in turn the battery storage. Second is about the battery swapping policy, which has to be brought out, and the energy as a service to be facilitated. This means decoupling the energy from the vehicle, and the interoperability has to be ensured. I think this move is very, very important from our country perspective. We are mainly the two-wheeler rich country. Most of 80% of the vehicles in automotive sector in India are the two-wheelers. So decoupling the battery, that is the energy part, from the vehicle is a game changer. However, we have few challenges such as how interoperability will be addressed, how much standards can define so that the innovation is not hindered. But finally, having said that, I think we need to see how this shapes up. But given the initial information, I'm sure the standards will address the larger issues. I'm also part of the standards formation and also leading the battery swapping policy in our country. So we are working relentlessly to issue and to release it as soon as possible. At every stage, all the stakeholders, including the think tanks, financiers, battery OEMs, vehicle OEMs, charging infrastructure providers, CPOs, everybody is in touch with us. We are continuously engaging with them. Next point is about the green bonds issuance as part of government's overall borrowings, mainly target the development of green infrastructure projects. India will now join a select group of countries, primarily, of course, European, which have issued such points. We can also expect this move to catalyze the development of domestic corporate green bond market. Green bond issuance by the Indian companies in the overseas debt capital markets have considerably lagged so far. So now, after the sovereign green bonds price at lower yields versus their non-green counterparts, it will also provide an added signal for the private sector to direct their own capital towards green investments. Initially, of course, it will be rupee dominated with a medium to long-term tenure. Of course, for green infra public projects, RBI will come out with a framework which will have details about the projects or the sectors that would qualify for funding under the sovereign green bonds. Lastly, in terms of the energy storage, advanced chemistry cell PLI, which is about 2.5 billion US dollars. So we have already received the bids. 2.6 times of the total 50 gigawatt hour what was at the disposal. We have received the bids for 128 gigawatt hour. This is almost 2.6 times subscription of the scheme. And this is a sign of three important things in the energy storage in India. First is Indian energy industry understands the need to change and is ready with the investments in promising future. Secondly, we can succeed in technical schemes. So this particular scheme was not the L1 scheme where the lowest who is going to quote is going to be qualified. This was on the basis of the QCBS mechanism, quality come cost-based mechanism, wherein 80% was mainly to the quality and 20% was to the financial. So we can succeed in technical schemes, not always need to go L1. Third is 2.6 times is just not a number for the bids quoted under the conditions mentioned. There are several other serious players out there who will set up the factories out of this scheme. So this scheme has brought out the reality of the shift, that is shift which has to happen. and the creation of the power storage ecosystem in India. We have imported close to 6,600 crores worth of lithium-ion cells in our country in fiscal year 1920. I think all of these are the welcome steps and will go a long way in addressing the energy storage requirements in particular in our country. Thank you very much. That's it from my end. Rish, over to you.
Thank you, Mr. Ranjit Singh. Really appreciate those insights. Fantastic linkages between the electric mobility and the energy storage, right? Why is it important? It not only touched upon just the vehicles, but you also touched upon the charging infrastructure, which becomes very critical to enable such a future. We have our, last panelist, Ms. Paramita Sahu, who heads the advocacy at Tata Power. At Tata Power, Ms. Paramita Sahu builds awareness and drives conversations on risks and opportunities emanating from the energy policy and regulatory environment for all verticals in Tata Power. She's a power sector expert and has over 3 decades of experience working with a lot of fantastic companies like NTPC, Tata Power, Tata Power Solar, etc. And she has published a lot of in-house thought papers to forge leadership of Tata Power in power infrastructure space. The way I also worked with Tata Power in the past, one of the very innovative utilities in India. I call that Tata Power as PG&E of India, just like California utilities are advanced and innovative in terms of adopting new technology and moving ahead in adoption of technology and modernization of the grid. So Tata Power has been a leader in that space. And I'd like to call upon Ms. Paramita Sahu to give her prepared remarks. Over to you, Paramita. Hello? Paramita, can you hear me?
Sorry, can you hear me now?
Yes, we can hear you.
Yeah,
now.
sorry. So I want to begin with a note of thanks for having me here. Indeed, privileged to be a part of this panel. I'll begin with a reference to India's articulated goal at the COP26 summit, 50% of procurement from green energy sources, which Trish, you spoke about, 500 gigawatt by 2030, and 100% of new vehicles to be zero emissions by 2040. Incidentally, Tata Power is at the forefront of all these sectors, transforming largely into the green space, at the forefront of electrical mobility. We are the largest installer of charging infrastructure. And also we are into distributed energy resources in many of the far-flung areas. Now, the magnitude of the target set brings to the fore the immense importance of storage, which have to be large in magnitude and diverse in nature. India is currently focused on a smooth transition to the clean energy space, not only through a large deployment of various technologies of energy storage, but also through domestic manufacturing, which Randir spoke about so extensively. Amongst the challenges we face today is that of a nascent policy framework. However, the government is working on it. The Central Electricity Authority, which is the apex technical body for the power sector, has already estimated around 37 gigawatt of storage energy, a storage capacity which would be required by 2030 to integrate the renewable energy available with minimum curtailment. And Tata Power Delhi Distribution Limited, our concern, has already set up this 10 megawatt battery capacity as a grid element, and they have been able to demonstrate significant savings in various aspects of network management. A tender for awarding the domestic manufacturing capacity for advanced cell battery systems has already been explained very well by Randir. At the level of the policy framework, before that, firm in the belief that only larger deployment will bring down costs, which are prohibitive at this moment of time for the grids to absorb. Firm in the belief that only a larger deployment will bring down costs, there are already 2 large tenders in the market for standalone energy storage capacity. Which is the battery energy storage capacity, which is 3 gigawatt hour for sale to NTPC and 500 megawatt hour for sale to DISCOMs. Now, one of the challenges we face is that battery or storage has not been defined as an element in the Electricity Act 2003, as has been the generation, transmission, and distribution elements. However, both the central government and the regulator have taken initial steps. An energy policy, like Yashwant said, is on the cards and there is a clarification which has been forwarded by the Ministry of Power that storage will be given the colors of the application for which it has been deployed. The central regulator has also been active in recent times. It's recently published the Ancillary Services Regulation. This, we believe, will pave the way for deployment and the demand for fast response energy systems. It's also working on the general network access and in the grid code, a set of regulations which would define how such storage elements would be connected to the Indian grid, what would be the transmission tariffs, how would the grid be operated, how are each entities supposed to behave, and how would the grid be managed by the system operator. So we believe that the policy regime, the policy framework will mature as we go along. These are my initial thoughts as far as the policy and the regulatory environment is concerned. Thank you.
Excellent, Paramita. Thank you so much. You brought up on a very important point that is also equally key in the United States when we talk about the interconnection, the tariff, and how the distribution system operator, particularly on the distributed side of the grid, are managing these assets because they put a lot of imbalance or variability in how the electricity must be supplied. So for example, in California, we have something called as Rule 21. Rule 21 is an interconnection standard. It's a tariff that really dictates how this energy storage must be interconnected in a reliable fashion to the distribution grid. But it also kind of tells how those energy storage communication capabilities must be exercised in a standardized fashion that allows distribution utilities and potential customers to create markets that allows them to become a very useful grid resource. So fantastic points. We really appreciate those insights. In the next stage, we're going to jump into some prepared questions that we're going to target specifically under understanding the issues that India faces and how the countries, both US and India, can collaboratively work together. I will start with my first question. We all understand, based on some of the comments that Mr. Randeep Singh made, we know that the lithium-ion battery is going through a big transformation, right? But at the same time, we also know it's facing conflicting decarbonization priorities. When I say conflicting decarbonization priority, I mean the generation or the manufacturing of lithium-ion battery for electric mobility, and also having enough capacity of manufacturing for addressing grid scale storage or behind the meter storage requirement. So India is at that cusp of advancing both renewable energy generation as well as has aggressive goals in terms of electric mobility. The question really comes is, what are some of the experiences? I'd like to call upon Mr. Randeep Singh in how India is planning to address these priorities, specifically with the battery energy storage production and deployment. So Mr. Randir Singh? Yes, you must be on mute. I can't hear you. So Pearl, is Mr. Randir Singh on the call?
Sir, I can't. I can't see Mr. Randhir. I'll just check with him if he's around,
Okay.
so he can join back.
Not a problem. If you can check in, he can join back. Until we wait for Mr. Randir Singh, if you don't mind, Parmita, if I ask you that question from utility perspective, because you clearly mentioned the 100% zero emission vehicle by 2040, and Tata Power is doing quite a bit in helping. Can you tell what Tata Power is doing specifically in trying to balance between the needs of the grid scale storage, which is important, but also advancing charging infrastructure and electric mobility? You are mute, Parmita.
Yeah, I'm so sorry about it.
There you go. No problem.
So, the charging infrastructure and the electric mobility space is in its infancy in India. We see a lot of promotional policies in the various states, and each state is doing its best to, through various measures, transform or quickly adopt the green practices for its mobility sector. For examples, the first few charging infrastructures were kind of given the places to install their charging infrastructures. There are very favorable policies being taken out in terms of how the private sector can also enter and complement the efforts of the public sector in setting up the charging infrastructure. The state of the development of charging infrastructure has not attained a level where it would right now kind of disturb the grid stability, but along with the renewable energy which is coming on, and that is providing a larger disruption to the grid. Because right now the balancing is happening through curtailment, and we don't want that to happen. And therefore, there are policies like flexibilization, which the central government is working on, flexibilization of thermal and hydro power plants through bundling with RE. Now, what it does is, in very short, also enrolls the generator to become a balancing agent other than the system operator, because the balancing takes place at the level of the generating node itself, because it's going to be bundled power. What the generator has to do, the original thermal generator has to invest in flexibilization systems, and that does not come easy. The technologies are just being tested. And of course, the policy framework is also not firm. The regulator has to accept it. And in India, we have power in the concurrent list, which means that the central policy can at best be guiding principles for formulation of further policies by the states as far as this is concerned. So we'll have to await the regulations being formed for it to become, kind of implementable. But as far as electrical mobility is concerned right now, it's at the initial stage, and I do not reckon that it is kind of causing disturbance to the electrical grid just yet. Thank you.
Wonderful, fantastic points. Specifically with respect to lack of foreign policy by both state and central, I think is very critical. I remember in 2014 or 2015, California was first state in the United States to formulate the energy storage mandate. At that time, it was 1.325 gigawatts of energy storage, but that was specifically targeted to address the aggressive renewable energy generation goals. So policy plays a very critical role, regulation plays a very critical role. And it only has gotten better since that policy was formed almost 6-7 years ago to where we are right now. So excellent points. Thank you. We'll move to our next question, I think, which is a very important. I've always seen India being a very cost-conscious market. I'm not saying specifically India, but entire planet is a cost-conscious market when it comes to energy sector. In India, I've seen that it's far more in terms of really understanding the cost becomes a very important factor in its deployment. So this is a question to you, Brian, is how the experiences from the US can help India in attaining its energy storage goals, with cost being an important consideration, specifically with your experience in pumped hydro storage.
Thanks, Rish. So I think, first of all, a couple of factors. One, as far as the levelized cost of electricity goes and storage goes, pump storage is the lowest cost per megawatt, per kilowatt, however you want to measure it, as far as an existing technology platform. That said, we also have to recognize that of these fairly large developments, that only roughly between 15 to 20% of the cost of the project is actually the storage generation, the pumping, turbine, and other electronic and mechanical equipment cost. The rest of it is the cost to build the facility, pour the concrete, and so in that case, it's like every other large infrastructure project, whether it's road or rail, or building a new airport. There are just costs that come with these massive capital exercises, infrastructure exercises, and we have to, just plan for it, try to modular, and they're scalable. So that we can come up with common designs, so that we're not coming up with bespoke projects every single time. And that's one of the factors about pump storage, is that you can, in fact, start producing very modular, say 400 megawatt pump storage facilities. Again, I mean, we're seeing this in USA. We're seeing this also up in places like China, where they're looking to rapidly expand the amount of capacity by going a modular route in order to hold the line on cost and hold the line on design and make things much more repeatable in order to deploy faster.
Excellent.
Thank you, Rich.
Fantastic. Yeah, thank you, Brian. Appreciate that. Those are some great points in terms of making it modular and how to bring the costs down. I think another important factor I was reading through the India is India has only about 3.3 gigawatts of pumped hydro storage, but the capacity, according to the International Energy Administration and CSTEF study, is 96 gigawatts, right? It's a huge 30x capacity potential versus where it is. So certainly a lot of, and also it's one of the lowest cost, along with compressed air energy storage system technology. So it does have a lot of promises in terms of what could be done for a large scale grid storage. So thanks, Brian.
And I'd add, Rich,
yeah.
Sorry, I'd add, Rich, that 96 to 120 capability is only for new. It doesn't even look at brownfield. It doesn't even look at repurposing existing hydro capacity in India.
Fantastic. Great. Thanks for that. We are just on time, but we started 10 minutes late, so I'm going to take that privilege to extend it for another 10 minutes. Apologies for running over time a little bit. We have another two very important questions I'd like to pose to the panelists. One is in terms of US-India collaboration, right? This is the US-India Smart Grid Workshop. We want to make sure we continue to foster this kind of collaboration. Jinglu mentioned about exchange, and so did Raghav. Some of the great exchanges happening between US and India, some programs that are already there between the Department of Commerce, USAID, Department of Energy, etc. in the US and the Indian government and partners. We would like to continue to see that in advancing both the decarbonization and electrification strategy. What are some of the energy storage priorities you would see are important for India-US collaboration, both from technology perspective and policy intervention perspective? I will pose the policy question to Tata Power, Permita, to you, and the technology question to EOS. So over to you, Permita.
Yeah. So I've been able to jot down some points. The first area to begin with, integration of RE into a centralized grid of the magnitude of India's is a challenge as compared to integration of RE into, distributed grids or microgrids. And same holds true for integration of energy storage. So we could learn from research in US on the deployment of energy storage and prevention of frequency fluctuations and flattening of the famous duck curve, which emanates because of increasing share of renewable in the overall energy mix. Another area is also the use of energy storage to reduce costly downcycling and upcycling of combined cycle power plants, which I believe is ongoing in US. We could learn that from that experiment and deploy it in our own flexibilization scheme, about which I spoke a short while back. We could also collaborate in devising a solution for the huge amounts of used storage system which would flow into the waste economy as a result of larger deployment of battery energy storage. Besides that, I would also consider research on alternate chemistry for cells, using more abundantly available natural elements like sodium cells, sodium-based cells or sodium-based chemistry cells, instead of lithium, for which we have to depend upon other countries for import. And lastly, some capacity building in code standards and the technical regulations for the more often used battery chemistries. Over here, I would like to just mention one aspect that in the recent past, in the current financial year, the Indian grid has deviated beyond the frequency band for 25% of the time. And that is not something, that's something which we would like to plug through the deployment of energy sources and storage resources. And I think there's a lot of room for very useful collaboration between US and India in how to manage the grid better in view of the rising renewables, and in times to come also in view of the large charging infrastructure which we would have.
Okay, excellent. Thank you, Permita. Those are some, I was taking notes while you were saying them. So over to you, Ashwant. What do you think, from your perspective, from technology, what are some of the areas we could potentially collaborate together?
Yeah, given India's target of having 50% renewables, 500 gigawatt by 2030, I think one thing what we should take from what's happening in the US, right? US is is clearly emerging as a leader in terms of development of range of long duration storage. We've been seeing a lot of technology companies offering in various technologies in terms of long duration storage. And the key for both companies in order to decarbonize and bring electricity access, which is more importantly for India and then security point of view in the United States, I believe is going to be long duration storage. And these, as Parvita was saying, these emerging technologies require, I would say, innovation, advanced manufacturing, and often they are all based on alternative chemistries and minerals, which are actually abundantly available both in US as well as in India. So in essence, what I would feel is both US and India should zero in on long duration storage as an area where they could collaborate. And I see both countries have materials, supply chains, they have the capacity, ingenuity to require to make this breakthrough in the space and also advancement, so that it is central to the electrification and the climate goals which both the countries have set forth with. So that's my take on this.
Wonderful. Thank you. I really appreciate that, Ashwin, for those insights. One last question, and then before we have our chair, provide closing remarks. That question is on the interconnection and integration with utility system, specifically with respect to managing grid reliably in real time. So I mentioned about the California Rule 21 earlier, which is interconnection standard that allows distribution utility to monitor and, if necessary, create programs that allows it to control it. In India, we also heard from the speakers that we don't have a policy, we don't have a tariff, we don't have interconnection requirements, and much of that is needed. So what are some of the requirements and potential collaboration do you see in this space that are very critical? I would like to pose that to electric utilities, because this is where the electric utilities plays a very critical role. And also, Ashwin, we can address it from the energy storage technology perspective as well. So what do you, Parmita? Any views?
In fact, we've seen very progressive regulations, draft regulations at this moment of time by the Central Electricity Regulatory Commission. We have the draft General Network Access Regulations currently. Now, this set of regulation defines how each element or how each grid element is going to be interconnected with the interstate grid. Now, we have state grids which are separate, but we are currently talking of the interstate grid. So it defines, and the interconnection regulations would kind of define what kind of transmission tariffs would be paid by each entity. For example, currently, as far as the battery energy storage is concerned, it has been defined as a generating unit in these draft GNA regulations, which means that it has been given the status of a generator, and according to the Electricity Act 2003, generation is an delicensed activity, and also it would have the advantage of not being liable for any transmission costs. No injecting entity will be liable for any transmission costs or losses. It's only going to be the procurement utilities which are going to be obligated for such costs, because at the end of the day, it's the consumer who pays. So it makes immense sense to kind of make regulations to make the DISCOMs upfront responsible for paying these costs. So it also relieves, the whole host of policies and rules we were having on waiver of transmission charges for renewable energy, for promoting renewable energy. A waiver was granted. It kind of relieves and kind of clears up that entire body of regulations which were in place for defining the transmission charges for each entity. It is very clear now. It's a procurement agency and the consumer who are going to be responsible. So that's the draft GNA, and that's going to pave the way for simplification of what we call the sharing regulations, which defines the obligation of transmission tariffs for each grid-connected entity. If I've answered your query.
Yes, that was fantastic. You kind of showed a lot of insights that I wasn't aware of. Thank you very much, Mr. Yashwant. From the technology perspective, purely looking from that interconnection requirements, both front of the meter, behind meter. If you can quickly, maybe in 1 minute, because we're running short of time, give your perspective before we kind of go into the closing remarks.
Yeah, this is something which is ongoing from a technology perspective. I think as we keep deploying storage systems, we are learning in terms of interconnecting with the state as well as the central grid. Paramita did talk about the larger GNA. I think that would definitely help in terms of access for the generators, in terms of getting access to the networks. But quickly to talk on the BTM side, I think it's more the state utilities, the state safety, CEIG, the state level guys have to understand in terms of what it is need to connect these and then appropriately provide the approvals in place. So we have faced some challenges, but with consistent what I would say explanation towards what the technology can do, I think we are able to move through it. But it's just a matter of time that things will catch on in India.
Excellent. Thank you, Yashwant. And that's an area I think is going to be another leapfrogging opportunity between US and India collaboration. So really appreciate that. And hopefully, India Smart Grid Forum can continue to, provide its technical support in not only just policy goals, but also technological trends. So with that, we formally end our prepared remarks from all the panelists. Before we go into the vote of thanks by Ms. Renee Subin, who is a U.S. commercial expert from U.S. Commercial Service, I'd like to specially thank the U.S. Department of Commerce, as well as the U.S.-India Business Council, who have brought in some of the best experts globally to address some of the energy storage issues and collaborative points between both countries, U.S. and India. And also like to thank ISGF for hosting it. They've done a phenomenal job for the last 8 years, including this 8th year of what we call US India Smart Grid Workshop. And I will pass it on to Renee for her vote of thanks and closing remarks. Over to you, Renee.
And please don't, you need to have a group picture also.
So we had one, Reggie, but we can take one soon after this as well. Yeah.
Switch on.
We took it early because some of the speakers were leaving, so we took it at the beginning of the panel itself.
Okay.
Okay, thank you, Rish. And I do realize I'm probably the last hurdle between all our panelists from India and their dinner, so I'm going to keep it very brief. I think from today's discussion, it's very clear that energy storage is going to play a very important role in India to help India achieve its power reliability, sustainability, flexibility, or power security. We also heard some great discussion around pumped hydro storage. And of course, in today's time, there is also a lot of focus on green hydrogen. What is of interest to somebody like me is that all these areas are still developing in the country, which means there is huge scope for growth. So as a US government agency that represents the commercial interest of US companies in India, our focus and our endeavors will be to help advance US-India partnerships, especially in these 3 areas. Well, on that note, I would like to conclude today's session, but not before thanking each and every one of our speakers who have extended their workday to be a part of our program, and some of them have actually gotten up very early in the morning to join us. Reggie, as always, it was a pleasure collaborating with you and your team, and I look forward to our continued partnership. So with that, I wish everybody a good night who've joined us from India, and a good day to others who have joined us from other parts of the world.